Hello, hello. Welcome to another cast stream. Going to keep working on the transpiling from cast to minicast. We are trying to make the hello world with standard library to compile there. It already works without the standard library, but STD uses a lot of features of the language, so there is a bunch of to-dos. In the transpiler, there are 38 to-dos left in this file. Probably not exactly all of them are necessary, but at least half probably. So let's go over them one by one. Hello, Nigel. Line 550. So this is where I'm casting. Okay, that's where I stopped, right? How do we do the casting? Actually, this is interesting. How do we do the casting? How do we do the casting? The camera angle is new. Yeah, do you like it? I don't know. I just moved it here because there's sun from the window. So this way it doesn't shine into the camera. Yeah, I don't know. Maybe I actually like it better. We'll see. The only thing is like this is where I usually put my cup. So I have to put the cup in a different place now. um okay, actually like this is immediately not very obvious. How do we do the casting? So we have a runtime casting system currently, which we might change in the future. But the way it is right now, we have the global cast map, and we need to look up the value in this global map in order to cast it. How is it done in the runtime in the JavaScript, for example, right? So when we have the cast, we are having the value and the target, and then we just call the function called cast get impl. Of value and target. So which means that it's implemented in the runtime, not yeah. So get impl is this. And casting by target is just a map in this case. So we would treat a value as something like the interface star, I think. This is actually like interesting. I'm thinking here. If we have like, so we are going to think mostly about the Go here for now, right? So how would I implement this thing in Go? You know, we can have type cast map, right? It's going to be a struct, and then we are going to have var cast map, right? Okay, and so how do you do maps in Go? Golang map. I'm pretty sure there is a standard maps, right? Go provides a built-in map. You just have map key type value type. So this is going to be like a map from value. into value, right? But what is the value in this case, right? Cast map. I can just do this. Just say that type value is interface empty. Is that what we do? Like it's literally the empty interface. So the question that I have is, what happens if I say, what happens if I say cast map foo is equal to 1, 2, 3? Interface can be replaced with any. Wait, there is literally the any type in Go. Is that new? Looking for any is not that easy. Like over here, they already use it, but I have not seen the definition of it yet. Why is it so difficult to search for it? Because it's any. Any is the built-in type alias to the empty interface, right? Okay, so just the alias. Okay. Whatever. So instead of value, we just say any here directly. Well, I mean, it's okay. We just can have an alias to any, which is an alias to an empty interface, right? So over here, I want to say like cast map foo empty rid. Invalid operands for binary expressions, foo and foo. Oh, this is in C, right? Comment this out. Target main Go. Assignment to entry in a nil map. Oh no. How do you make the not nil map? No. And to make it first. One, two, three, right? So the question is that I have is something like this. If I have a function f, which is going to do this, which is going to like print that, you know, which I'm going to call over here, right? Like this is two different foos, right? Although this is an empty struct, so they're technically equal to each other, right? It is supposed to be different things, right? No, but it's not. So the question is, how does this work? What exactly is the equality of the object? I actually expected this to not work. I thought that the interface, the empty interface that we like have here as the key of the map, is basically the vtable plus the address, or is it because it's the zero size type, so it actually has the like the address can be erased? Does Golang have zero size types like Rust, where so like it's basically they are all equal to each other? Let's try to have the field of an int type or something here. Does this Is this going to work still? It still works though, right? So if I say over here that foo field is equal to 2, then it's going to not work, right? So it's actually based on the value, right? Okay. I'm actually wondering how this works then. This is interesting. Hash table. Map types or reference types, whatever. Key types. Map keys can be of any type that is comparable. The language spec defines this precisely, but in short, comparable types are Boolean, numeric, string, pointer, channel, and interface types, and structs or arrays that contain only those types. Wait, so like it cannot be anything technically, right? Only specific things. But how do you compare the interface types? Right? Like, isn't anything can be represented as the interface type? So like comparing the interface is different than comparing the structs directly. Is that right? Language spec defines this precisely. Let's see, comparison operators. In any comparison, the first operator must be assignable to the type of the second operator, or vice versa. The equality operator is comparable types: Boolean, integer, floating points are comparable and ordered. Two floating points values are compared as defined in the 754 standard. But the 754 standard does not make it ordered, right? Because of the nuns. All right, whatever. Actually, like, how does this work in Golang? Or like, they pretend to be ordered, but they are not actually ordered. Can I say? Can you do none? Var x float is none. You cannot do none directly, right? Can I say like 1.0 divided by 0.0? Division by 0, invalid operation. Var 0 float is 0. Can I divide by 0 like this? Because that is not going to know it, right? It is infinity. Hold on. How do I do the none? I 0 divide by 0? Yeah. Okay. X is less than X. X is equal to X. False. Right? So none is not equal to none. All right. Just was wondering. Doesn't this mean that it's not an ordered type? Anyway, complex types are comparable. String types, pointer types. Pointers to distinct zero size variables may or may not be equal. Okay, there we go. So you actually have zero size things here. Comparison may be based on the type and not the value. Well, I mean, I think that the interface is basically like the pointer. Is it not? So interface types that are not type parameters are comparable. Two interface values are equal if they have identical dynamic types and equal dynamic values. No, it's equal the value, not the pointer then, right? Okay, so it actually is like deep structural comparison, right? But then it says that there are certain things that are not comparable, right? So what is not comparable? Like a function maybe? Or like, I mean, function, I would think it's a pointer type, right? A comparison of two interface values with identical dynamic types causes a runtime panic if that type is not comparable, right? So what's the not comparable type example? Oh, you have like a type that is strictly comparable, which is comparable and not interface types, nor composed of interface types. Oh, no, okay. That's different than I thought it would be. Alright, whatever. Golang example of non-comparable type. Non-comparable type is one that's going to be used. Slices? Wait, why is slices not comparable? Huh? Maps are not comparable? Huh? There's no way. Functions. So function is not a pointer type, right? Like this is different. So can I say f, which is a function here? And then if I do this, then we're actually going to crash hash of unhashable type main.foo, right? There we go. Got it. And like you cannot have your own custom hash implementation, if I understand this correctly, right? Golang custom hash function. You cannot override. So yeah, because there's no traits and shit. So you just like convert your key to the comparable type then. Which potentially adds overhead, but okay, whatever. I'm just wondering if I like it means that I wait. Here's another question then, right? Here's another question. If I have like an enum, like it's only when I don't when I compare this thing where it cannot happen, right? But if I have basically, you know, I have like a type, like a function, like behind a reference or something, right? Like struct, which is going to have the f inside, and inside of foo I have f, like this. So like, since this is not behind a pointer, this is still going to be not a comparable type, right? Yes. But if I make this a pointer, then this will work. Well, then it will compare the pointer instead. So pointer is different from the any interface. In case of the any interface, we are going to compare the actual like contents behind the pointer, but then we lose the type information. Oh my god, Go is so weird. Okay. Anyway, so what I mean is that we have a value, and the value is just going to be the any interface anyway. I guess that is okay. Well, I mean, is it okay? Because I'm trying to find in this map the... I'm trying to find in this map what? The key, which is a function actually, because like the traits are functions technically, right? Yeah. Well, I mean, we can have a pointer, right? Pointers are always correct then. But if I use the pointer over here, if this is like a pointer to value, like this, right? It means that this foo and this foo is actually two different foos. Wait, how do I get like the reference to foo and make it like a star any? Can I not have a reference to the empty interface? Like I need to first say that foo as any is foo. Is that right? And I have reference to foo any. I'll use foo any as star value in map index. Star any does not implement star value. Star value is pointed to interface, not interface. Wait, what? But like value is literally any. Hello? Wait, what? So like this is not exactly the type alias? It is something different? Am I stupid? How does Go work? Golang type alias. Type this is that. Oh, so like type value any is different. Type value is equal any is different than type value any, right? So this is a new type, and this is the alias. Interesting. How do you cast things in Go? This is like dot any foo is not an interface. Like, do I have to do it through the extra variable? Yeah, so now like it's nil, which means that it doesn't exist in the key, because now we're comparing the pointers, and these are pointers to different things. This is very weird. So like, let's say that I have like a value, right? Which is like, I mean, yeah, I guess like a value is actually, because you don't have the sum types and stuff in Golang, this you just represent it as the interface. So yeah, and then you lose on the type safety, but it's simple language, I suppose. It just means that I need to be like kind of careful if I want to store it in a map. Changing the representation will change the comparison thing, right? Also, doesn't this mean that I cannot have the recursive structures? Right, yeah. Like, what if I had the, you know, like the singly linked list, for example, right? Which is a struct, right? Which has next, which is singly linked list. Like, right? Like, this is not doable. So you need to have this behind of a pointer anyway. Wait, why is it still complaining? If this be kind of a pointer, I should be able to do that, right? What? How do I define a single linked list? The AI thinks that this is correct, but then the Golang itself says that it's not. What? Oh, it's equal to struct versus struct. Oh, of course. Of course. Right. So in this case, if I want to compare on based on like the key, which is actually the value of the list, right? So we have the list where we have the value, which is like any, I guess. So yeah, and if we compare, we would compare based on the thing, based on the pointer, not based on the value of the next values, right? So only the first value is going to be compared deeply. How do you even write code in Go? Ew. Well, you don't use the built-in map. You create your own custom map, right? And then like things with custom functions acting as the comparisons. So we're just like looking into how to implement the casting, and the casting is most importantly just is the we're casting types as traits, and we're still doing it at runtime because we want to prevent monomorphization for now. Still, I think. Well, I can have like the key of the cast map to be like castable, right? Or like I don't know, like value with ID, you know? Value with ID, because value with ID then would be an interface. Wait. But then it's not the interface, right? Like it's literally just ID then. I say type ID is int, right? I can do that. So it's going to just map from int. Sure. But we will have like the interface value with ID. And can you have the fields in interfaces? ID int. Type value with ID. It's interface, right? Like this. And expected semicolon. What does this even mean? Oh, because ID is a type. And this is a type. What does this mean if I just have the interface with two types inside? What does this even mean? Is this the interface which is one of these types? Where's the table of contents? Learn. Docs. spec interface. Right, like basic interface, you're supposed to have the methods there, but what I did there was not a method. An interface representing only the type int. Interface representing on type with underlying type int. What does that mean? What does that even mean? Interface representing all types with underlying type int that implements the string method. Okay. An interface representing an empty type set. There is no type that is both an int and a string. Oh, okay. What? And you can have the unions. What's the definition of the underlying type? Each type has an underlying type. If T is one of the pre-declared, the corresponding type is the underlying type itself. Otherwise, T's underlying type is the underlying type of the type to which T refers to in its declaration. For a type parameter that is the underlying type of a type constraint, which is always an interface. The underlying type of string, A1, A2, B1, and B2 is string. So it's like the underlying type is like basically the resolved alias. Well, because this is not an alias, right? This is a new type. This over here is the type alias, right? Got it. So an A type is always different, otherwise the underlying types. Yeah, so what I want is I want to have a value with ID, which basically has a method ID, which returns the ID. Can I have a method like this with a name, with a type name, which is like the value, which is the method name in Go? It seems like I can, right? So basically, we want what we want. What we want here is we want to have the function like, so we want to implement cast, right, of a value which is value with ID, and target, which is value with ID. I think if we like do value and target, which is a value with ID, then they both have the same type. Is that right? And then we have the implementation, which is just value. We don't care about the ID of the value, right? Which means that the cast maps like map ID value. Is that right? Right, so we say that cast map, we first do based on the target ID, right? Runtime go in the making. I'm just like looking if I want to change this. Like, do I implement this in the basically? Do we have casting in minicast, or do we have or do we like convert the casting into some like primitive operation in the minicast? Is the question. You know, I feel like we can have the casting in minicast. Like this. Maybe. Rust, we do this completely at compile time. Yes, I know. Yes, no, we will have the option to do both. That's the that's what I'm trying to do, right? We want to not monomorphize to save on the compile times specifically. Like, but then later I won't have the option to like toggle this between being runtime or compile time. Well, whether we want to have faster runtime or faster compile times, basically. Kast map. This. Target impulse is that, right? If target impulse is nil, then I want to say cast map target ID is equal to make map ID value, right? And target impulse is this, right? And then we say target impulse value ID is equal to implementation, right? So that's how we implement the cast. And then similarly, we get the cast implementation. Get cast implementation. We just have value and target without the impulse. So we just say target impulse value ID, and that's what we return. This should return value, right? So like something like this is what we want. So we want to have value with IDs specifically. So like, at least like for now, that's what we do. Like later we will have the more complicated things, but right now I only can implement the traits for concrete types anyway, and they are having IDs. Yes. So like, yeah. Let's implement this in minicast for now, but then later we will probably have some, I don't know. I might later get rid of this from minicast. We'll see. So the minicast transpiler, if we have the cast expression, we will literally just have the expression cast. Right, I'm going to cast value target, right? I'm going to cast value is transpile expression value, and target is transpile value target. You know, so I have a new thing called cast value is expression, target is expression. Wait, hold on. Is target an expression? Target should be like what? A target should actually be a type. Wait a second. This is no. How do I implement this in minicast? Because targets are, in case of traits, the generic types, which is a function returning a type. You know, I don't think. No, hold on. I don't want to do this in minicast. Because I mean, I can do this, but then I will not be able to type check. Is the issue. I don't think I want minicast to be like untyped, right? Yeah, like this actually requires generic types. The target is usually not a type, no. The target is usually the generic type, which is different from a type. So like, and I don't want the minicast to have generics, right? Because that would probably complicate things. I don't know. Let's go to the minicast self-hosted repository here, and let's see. Here's my minicast test, right? Wait, hold on. Did I not build? Did I merge your pull requests? I did, right? There's something that I did not push. What do we have here? Kast mini compile subcommand. Yeah, which like is whatever. My language server doesn't work, Nigel. I think that's after your pull request. Unless I did not compile something here. Which maybe is the case. Let me try. Yeah, no, I think it's just that I didn't compile after merging your and pulling your changes. Okay, no, everything is okay. Never mind. Okay, so we have the mini cast here, right? We want to cast. So here's the example, right? All right, what we want is to like parse a string. What we want is to parse a string. So how would we do this? Let x int 32 is parse 1, 2, 3, right? How do we write this code in minicast? That's the question. So in regular cast, we say that parse is a generic t, which like parses a string and returns the t, right? But we cannot do this in minicast because we don't have generics. So the question is, what is the parse? What even is the parse function? Well, first of all, we have the generics, right? Being type erased. So like we actually have a function that will return a function, you know. So this is yeah. So we have the type t, which is a type, right? And this returns a function that takes string and returns t, but we cannot specify this type, so we instead say any here, technically, right? That's what we transpile into. So now I have the t, which is the runtime type information, right? And then we want to say t as parse, dot parse as, basically, right? Oh, wait, I see what this means, right? Because we have the any type, right? Because I cannot return t. Yeah, generics like our type erased. So we erase the types. Anything that is generic is replaced with any, basically, right? So we have the parse, which is a type, which just has the parse, which is string into any, right? Because this, oh, wait. This is what we format it as in presence of errors. Yeah, you know, like, because by default we have the generic type here, and this is t. So what we do is we replace the generic function into the type like this, and we replace all of the generic arguments with any, right? That's what I compile it into. Then yes, then this over here is a concrete type, which we can get the ID of. And over here, this we can get the ID of at runtime. And we can like query the implementation of the trait. That makes sense? So the only question is, how do we convert them? Right? I need to be able to convert the thing. And like, but by default, this parse would actually be a function that returns a type, right? So like, this is what we want it to be. This is a little weird here. Oh wait, I think I know what we can do. I think I know what we can do. Does minicast have casting like in C? Not yet. No. And I'm not sure that it should be there. Well, I mean, for the primitive types, we want to have some form of the thing, but we can do it with the native expression. So maybe it's not necessary technically. The question is like, when I have the parse in the cast itself, right? It is the generic still. So what we currently transpile them into is we say that parse is basically a function which takes t type and returns a type, right? That's what we do right now. It's a higher kind of type like this. So we actually construct the type at runtime over here. Oh wait, does this mean that we should like say t as parse? Yeah, like basically what we want is we want to call this parse t with like this, right? Because that's the result type. But we cannot do this in minicast because we don't want to compile time evaluate, right? So how do we do the type checking? Unless we say that the as expression, like in this case, this is going to be any, so we can do anything with it. I don't think so. This is not so easy to transpile when we have like the types. And like in JavaScript, this also works because in JavaScript the functions can be the keys in the map, but in Golang it cannot be. And then we also don't do the type checking, of course, at all when transpiled to JavaScript. The type of A as B is always known in cast before minicast. Yeah, technically we do know the type there. So what does this mean though? Like, I'm trying to figure out what is needed in minicast. Right? But the type of this basically contains the runtime type, right? So like the type of t as parse t is literally parse t, which is like we like again, right? We have this as a generic type, right? So we will have still the t here, right? So we basically but then yeah, we can like convert that type where all of the runtime types get replaced with any type basically, right? So we can have the type annotation here. Is that what you're saying? Yes. So like this can be treated as any, but we then can do the type annotation. which will automatically be the thing with parse being the string into any, right? So we don't actually like convert this. Well, I mean, we do convert this, but like, yeah. But basically for every... Well, there are some like generic things and some are not generic things. So like the question is, do we basically like... Because I still need to have the type definition of this thing, right? I cannot have an inline struct. So we would have a bunch of parse types for every cast expression. Or something. But like if I parse like if this is not the runtime type, but if I actually try to parse in this case the int32, right? Then we know that this returns an int technically in cast. Well, this should be like parse like int32 type int32. Like this is like a constant, or which is the runtime type information about the int here. This technically returns any, but any is like coercible. Yeah. To the end. Okay, well, I mean, this is cursed, but yeah, I don't know how we can do it better yet. If not monomorphization, of course, right? Monomorphization is obvious. I'm pretty sure that this is like literally, we are following Swift here. So I think this is the way. Let me open this thing again. Can I reset the zoom somehow? So what, yeah, you have like over here, protocol area, float area, avoid star, smallest. You cannot monomorphize it if it doesn't even get used. What does that mean? I mean, of course, yes, I will have to monomorphize when it gets used, yes. To know what are the monomorphizations that we need to use the thing. Of course. That's how it works in any language. With monomorphization. Smallest. Right, so like, yeah, you see how over here, this is what the Swift transpiles into, basically, compiled into. You have like the void star. This is basically the any type, right? And this over here, so this over here is the trait implementation, which is passed as the hidden argument. But the question is, there we go. Array is collection, right? T. So we have basically the array of t's. So here's the code in Swift, right? We have a generic function, t shape, and we have an array of t's. And we want to calculate their total area, right? So what we have is the implementation of the shape trait for t, because that is present in the trait bound, but we don't have the implementation Or what? Like this over here, I think, no, arrays collection. Yeah, arrays, like basically array is the type that implements the collection trait, but that is not explicitly set here, and instead we retrieve the implementation of the trait at runtime here. So this is the implementation of array as collection type. Right? We have the runtime type information, and this is the implementation. This is more typed, but yeah. Type reflection. Yeah, I think like the question is what I compile this into. Oh wait, I think I know. Actually, one of the easy ways of doing this, right? Because right now, actually in Kast, I know this at compile time always. Although I thought this would not be the case forever. Because I know this at compile time and I know that this is a trait. We basically instantiate the trait with like t being like nothing, being still the runtime value. And we get this type. Yeah, which is how we get this anything. Yeah. Okay, I think this is literally what we transpile this into, actually. So parse is going to be that. We have replaced all of the generic arguments with any's. Which means that value is expression and... so target is going to be not an expression. Target is going to be a type. That's what I want it to be. Right? So we still cast values into types. And that way we can type check in minicast. Right? So target... let me fix this. Right? So when I cast value and target, we just print expression value, write as, and print type target. Okay, so we don't just transpile the value, right? We actually don't do this. We actually don't do this because we know that this is a value here. I'm going to see if this is a generic, then we need to do something specific. Are you also taking library users consideration? You child the paper that I mentioned separate compilation. Yeah, I think so. Although, I mean, I'm not thinking about this right now, but I mean, yeah, I'm not doing separate compilation yet at all. So we don't do transpile value. We say what? We say target is cast target. How about this? So cast target. Cast target. Target is value, and I should give the mini type, right? So what we are going to do here, we basically say that if, so yeah, what's the value here, right? Target value await inferred. I'm going to match this, right? And if it is a type already, I think I don't do this yet. Anyway, let's do what to do here. Lizard wizard, hello. A Linksider is a game, yes, that you can try and wishlist on Steam. Thank you. So if I have a generic, if I have anything else, I mean, technically we only like cast to generics. I think I don't even cast to types yet in my actual things. Reminds you of the old website games, mobile games. Well, I mean, it's a simplistically looking game, I guess, which is why I'm not really going for the aesthetic of the retro games, though. Much. You can see that this is having the pixel art, but at the same time we are rotating the pixels, which is not what you do in retro games. But yeah, if you like it, you try it. The demo is like around 1 hour of playtime if you try to go for all the levels in the demo. You also said Nursel is also working on Linkstar with me? No, it was Davey. Although Davey now works with Nursel instead. We have to. Right. I need to like basically like set a date probably on like when I start working on Linksider instead of working on Kast. I don't know when should that be. What's the middle of the year? The month number 7 in July. And then until the end of the year we do the Linksider. No, but in the end of the year there's going to be the Advent of Code. I will want to do the Advent of Code with Kast again for sure, at least. Maybe some other things. I don't know. I don't know how long it requires. I mean, we can also like try like alternating like one stream of doing the Kast, one stream of Linksider. That's another possibility. Success of the target go, then your game logic can be in WASM instead of JS. Yeah, I know. I never compiled Go to WASM, but yeah, I know that it's possible, so we might look into that. Yeah. But I'm not going to rewrite Linksider in Kast, or am I? So right now, this is going to be the line 415, right? So we literally have the generic. as our cast target. And what we want, if this is a generic, here's what we're going to do. We have the function. We are going to basically call this generic. Wait, actually, wait a second. No. Wait, no. Yes. Because like I want to only have one implementation of this. Like I know the result type of the cast expression here, right? But this might be not the generic one, but the monomorphized type basically. Right? But in order to return the implementation at compile time, I still need like this generic thing, which is the completion target. Yeah. If that makes sense. So I want to actually call this function with the new thing. Right? Interpreter call. And no, we want interpreter instantiate. Yeah, I think I actually want to instantiate this generic with the argument, which is going to be a new thing, which is well, it's actually interesting here, right? Because we can potentially have multiple arguments to the generic and everything. I do want to instantiate it with what? With a new not inferred argument, actually, is what we want, I think. So that we can infer the shape of it and everything. Hold on. When we do instantiate, we say the argument, right? Do we say that the argument type? We wait for instantiation name. No, that's not what we want. Actual result, generic function, generic instantiations. Find in generic instantiation. I don't do the type annotations here, right? I think I don't. Yeah, we just call untyped function here with the argument. Which I mean, I can like type annotate this new value that I'm getting. Okay, but let's say that I instantiate with a new not inferred thing, right? And then we basically will have instead of any type here the not inferred something, right? And what we could do is we could like convert the not inferred into any's, right? Another option, maybe better, would be if this is a generic. We know the pattern here, technically, right? So I actually know all of the variables. Right? So I need to actually construct a value where every binding is replaced with like a specific value. Right. Yeah, I think I could do that actually. So we have a generic. Generic has a type, which is a type generic, right? So that's what we want, type. So generic type has the arguments, which is a pattern, right? And I want to construct the pattern where we replace all of the bindings with basically a specific value, which is going to be the any, right? Okay, construct generic construct pattern value with bindings as any, right? That's what I want. Type args pattern. So this is the arg, you know. So construct pattern value with bindings as any. This is going to take the pattern and return the value, right? So we're going to match pattern shape. Here's all the patterns, right? If we have a placeholder, then we just, so placeholder doesn't matter. We just say value new not inferred. Scope span. I need to see the scope though for this to work. What's the scope? I'm gonna select context, interpreter, scope. Is that the one? No, that's not the one. Wait, what is the scope? Oh, we have interpreter scope T option. Okay. So this is. And wait, actually, we want. Actually, we want to have no scope here. Right? Because this value is like the generic thing, which, yeah. Yeah, I actually want the non-scope here. Because, yeah, it's not coming from inside of the interpretation. We don't want to actually infer this. It's going to be ignored, so it doesn't matter. Okay, if we have a reference, why is there no type definition? If we have a reference, met referenced, then need to have value in third span. So we need to construct a reference, which is mutable, right? And what else do we have there? We need to have place, and place is place initialize mutability and inherit. And value is going to be construct pattern value with binding reference. Right, like this. If we have a unit, we have the unit value. If we have a binding, so over here we have a binding, right? And we don't care about the bindings. So we just say that this is the any value. Any value. So I need to like somehow get the any value. Is it like the constant here in this module then? Let's say like any value is value in third. And you maybe like it's probably like a blocked. What do we have in blocked value? Yeah, I need to have like, oh, but the type, oh my god, this is impossible. Yeah, we have a blocked binding, and this is going to be the bind. Okay, actually it's not any, right? We just construct the value, which is this binding already. That's a little weird, but it's almost like there should be a different way. Like I should just evaluate the body of the generic without pattern matching the arguments. That's all that I need to do. So construct pattern value with bindings as any. Like I think like we don't need to construct. We just evaluate it without giving it the arguments. That's what we want. Yes. And then any bindings that we have in the type positions would just be replaced with any's. So we don't do instantiate, we do something specific. And like I don't even call the function, right? I just evaluate it. It's almost like this should be done in Kast itself, maybe. So that is done once. Like when I call the untyped function, right, we actually supply the argument here, but we don't want to do that. I want to just evaluate the body. Using what? What do we have in the, like, we using the captured scope? But not exactly the captured scope. The captured scope with the bindings injected. So the one that I use at compile time. Right? We say inject pattern bindings. Which is what I do when I compile a function. Do you have a generic? Right, so here's how we compile a generic, right? We say inject pattern bindings here into the inner state. I enter a new scope, right? I create a generic. This is my definition. Compiled, uncompiled. Where am I capturing the scope? It's not in the finished compiling, right? No. I'm injecting pattern bindings twice here for some reason. Oh, wait, it's because I'm compiling it, right? But the actual captured one is added when I'm constructing the generic. That's right. So yeah, I'm capturing the it at runtime, not at compile time. That makes sense. So it's not the same thing as I do in during compilation. Okay, maybe fine. Let's try construct the argument there. Seems like extra work though, which probably can like not be done. So we want to construct a value with bindings. Oh wait, hold on. I think I have done this already with bindings. No, I think maybe I do this somewhere in the substitution of the bindings actually. When I have generics, I feel like I've done this already, so I can use the existing code. When I substitute generic over here, the type of a generic, right? Basically, I substitute pattern and inject replacements. That's what I do. Right? This is what I do. So we have a one pattern and we return a different pattern. No, but what I want is I want to substitute pattern and and construct a value. It's a little bit different. Okay, but the code is kind of like the same. Kind of. Yeah, not exactly. Okay. Okay, fine. Construct pattern with value, pattern value with bindings. Not as any, just with with bindings. So here's what we do, right? If I have a binding, then we return. So this over here is binding. We construct a value blocked, which is a blocked value binding. And the type of this binding is the pattern data signature type, right? Value inferred span. That's what we do. So I don't have the any value. I need to like extra construct this. I need every time from scratch. There's a pattern binding which has, oh, it has like bind mode. Oh no. Bind mode binding. All right. Okay, so over here, I'm going to say that match bind mode with claim, and then we do this. Right? But if it is by ref, we say blocked by ref. What? Is it a boolean? It is a boolean, right? So we have a blocked value ref, claim ref. Wait, what do we have in blocked values? Claim ref and field ref. Claim ref. I mean, we don't have references in generic. You know what? Let's just fail here. It's okay. We say whatever. We in generics we only claim the arguments. So yeah, now if we have the error, this should never be the case here. If we have a variant, this should never be the case here. So but the tuple should be done, right? So tuple, we have the tuple of, and to construct the value of this tuple based on all of the arguments, right? Yeah. So we have parts. Yeah, so what I want is I want to create a tuple type value inferred. Do I have type in the tuple pattern? No, I don't. So I need to say that type is a pattern data signature type with inferred type shape expect tuple unwrap, right? Okay, now this tuple is we're going to construct from the parts, and I think so. I'm going to create the empty tuple here. Tuple is this. When I have the parts of the tuple, I need to go over the parts. The part is the pattern tuple part, right? So this over here, we're going to match part. Unpack, we're going to ignore this because I don't think I ever do this in generics. And if I have field, in this case, and say that label member is, no, I need to say like name is label map label get name, right? And then we say tuple is tuple add name field, and this should be like the value. So construct pattern value with bindings of the field. Okay, there you go. So this is going to be what? A tuple value tuple ref, right? But it should not be a value tuple ref actually, because I need to. Okay, so this over here is the value. This is the field value, right? field value is this, but since we didn't want to construct a tuple, we need to construct a place. We're going to say place in it. Mutability is inherit with the field value. Okay. No? Logic branch has type place tuple. No, yes, because we want tuple field. We want the tuple field to be of type value tuple field. Oh, it needs like the type fields too. Oh my god, why? And the span? Why do I need the span for here? Alright, we have the place, but then we need the span. Sure, let's just have the span like this. And then let's have the type field. I need the type field now. Which means that I need the type to be here first. Unnamed index ref 0. Match label. Some name. Some this. None. Let type field and name. So in this case, the type field is going to be type tuple get named name. Well, this is the name. Okay, and in this case, I need to like figure out the member. Member is tuple member index unnamed index plus 1, and we return type tuple get let type field is type tuple get unnamed index. Type field none. Okay, there we go. That should do it, right? Okay, so now we have constructed the pattern value with bindings. So we want to instantiate it here, the target with the argument. I need to give it the interpreter state here, which is the yeah, this context is needed, right? So we say like context interpreter, and give it the span. And I say let result is this. Okay, so what do we do here? We have the result, which is a value, right? And this value must be a type, right? Which we then transpile. And when we transpile, we also need to substitute all of the bindings with with any type. This is difficult here. So we say that result type is result value expect type. Let's just unwrap here. Yeah, but like this type needs to be substituted. Well, maybe we don't do the bindings. Maybe I actually replace the binding with something. Maybe I don't do the binding here. Because then I could just like transpile the type. I just need this to be... Yeah, you know what? Yes, I know what I can do. I can say that the blocked value binding here is going to be the new binding. And we can like treat, like, we're gonna make this a dedicated binding, which is getting converted into the any type, right? Yeah, a little hacky, but... So what's a binding, right? We have these things. Can you just say binding with like something? With I don't know. You know what? Let's just say ID here, a special ID, with ID being any type ID. Wait, can I do that though? Like, I mean, because like the generic arguments are not necessarily types, right? That's the thing. Wait, but how would I even transpile the const generics then? Right? Well, I mean, they cannot be present in the type anyway in minikast. Any type ID. Yeah, how about this? We just say over here that any type ID is ID generate. Okay, that fixes it, right? So we have the result type, and then I just literally just transpile the type, which is a result type, right? And this is supposed to be relatively easy. It's just like, so over here, right, we have the type, which is a blocked, right, value. Oh wait, hold on, I already doing all of the blocked values are already the any types, right? I already do this, so I don't even need to like hack into the ID in this case. Yeah, I don't need the ID hack. Let's not do that. All right, let's see now. Now the next is line 350, which is context type. Okay, so we have a value which is a context type. This is when I am transpiling something. Context type. I think this is just going to be I mean, do I need to do anything here? We have value context type. It has the ID, right? So I think that this is what we do, right? So how the question is, how do we represent the context types? Did I not do that already with the current context? Yeah, we have like context type name. Oh wait, we have context type name, right? What is this ID? Yeah, we have value context type. It gives me the name of it, right? If I want to have the value, it maybe I should just do uninitialized here. Maybe I'm not sure. Like, do we have the? Do we need this at runtime? I'm not sure. Line 179. Okay, now we have the type context type, and this can just be any alias to any. Well, I mean, I can have the context type, yeah, but yeah, let's not do this here. Let's do any and do uninitialized on the values. But maybe I will actually need to do something later. Line 222. So this is where we have the pattern tuple. So how do a pattern match with a tuple? That's a question. Parts. When we pattern match, we should just like go over the things. Pattern match, what does this return? The mini AST expression, okay. Tuple. So we basically create a then of this tuple. Oh, this is like list map function part. This is going to be a pattern tuple part, and this should give me the mini expression, right? So we match part with unpack, then I say to do, but if it is field label field member is match label with, if we have none, member is tuple member index unnamed index is unnamed index plus 1 member. If it is some label, then it's going to be tuple member name label get name label, and then we say so this is where I need to pattern match the field with the pure place expression, which is a field of object, which is the current place expression, and the field is member name of the member, right? Okay, and then we don't do the unpacks yet. And maybe we will not need to, hopefully. Line 194. So, and then we do the does match also, right? Which is very similar. So pattern match is when we know that it matches. And does match is when we check that it matches. This should be the expression which evaluates to a boolean. So what? It should be like an AND here, right? Yeah, we need to, instead of doing a then, we do this list. Where instead of pattern match, it says does match every field, right? So every field, and then we need to do like list fold. Like we fold in any direction, it doesn't matter, right? We fold left. And over here we have function AB, which should return like AND AB basically, right? Mini AST expression. And then we start with boolean true, right? Yeah. Is there like fold left, but like which start with a single one and returns an option? You know, like reduce? No? It's okay. We can start with true. It's a little bit of wasting, but it's okay. So I want to have an expression which is the end. End of two expressions, right? And similarly, we'll have the or. So we have end AB, then we print expression A, write end, and then print expression B, right? Well, I mean, I can do it then, and like, yeah, but this is short-circuiting, so it's better, supposedly. Or line 256. Oh no, I have unpacking in pattern matching. There is no way. Where do I have it? In Kast standard library. It's in the exam, like in the, okay. This is where I have it. Oh no. Yes, this is literally what we're compiling here. This has the ... Okay, it's probably not that difficult, especially if it's just in the end, you know? Yeah, if it's just in the end, then it's easy, right? Let's say this, had unpack is ref false, right? Over here, we just didn't say over here, had unpack is true, right? But I'm going to say unpack like pattern, and I will say that if pattern shape, we're going to match pattern shape, right? If this is the pattern placeholder, then we don't do anything. But in the other ways, we fail with log. Okay. Right, so we want to allow the trailing ignored ellipses, right? Yeah, and then this expression is just boolean true, right? And then over here, I don't, yeah, like if if it is unnamed, I guess, then I cannot do that, right? So over here, I say that if add unpack, then fail with luck. All right. And same needs to go about the does match. Then add unpack, false. My new favorite hobby, waking up and turning on the news because I know that America did something bad. Right. It's the whole world is doing everything bad. Like the world is competing who is the worst. Okay, line 567. Now another unpack. This is an expression. Hold on. So where is this? Over here we have a dot dot dot. Oh no. Well, technically over here I just want to copy the thing. Okay, how do we implement the unpacks properly, right? I need to... Oh, over here I'm doing the statements anyway, so I'm assigning the fields. This one is actually easy. Because I can, go over all the fields. Technically. Right. Yeah. Yeah. So the pact must be the type, right? So pact type is pact signature type we inferred type shape expect a tuple option unwrap, right? So it must be a tuple. And then we go over the fields, pact type, tuple, and we do tuple iterate function member field, which is tuple member, and type tuple field into something. Right, so over here, I need to add a new statement. So I want to assign field is field name, and the value is going to be something. Okay. So yeah, let's have over here we have assignee member, right, which is going to be match member with. So if this is name, then it's going to be name, right? But if it is index I, then it's going to be not index I, it's going to be tuple member index unnamed index. Unnamed index is unnamed index plus 1. Member match member unbound value member. It's literally over here. Oh my god, why are you sit? Oh, camel, This pattern measures these things, but expected to which measures of type tuple. Wait, what? Why? Why is it expected to be a tuple member? That's not true. Oh, wait, because okay, because this one has actually like member and field. Okay, got it. So maybe I only need to annotate this then. Right? Because OCaml can actually infer this, or can it? Who knows? Field name. So like field name here, which I assign into, is member name of assignee member. And now the actual value. Now the actual value is the packed expression, right? So I need to first calculate the packed expression. Shouldn't this be a place expression, by the way? Let's have a fine. Let's have the packed name is generate name packed. So we let var, right? So we generate add last two statements. We need to add the thing which is called let. Var is packed name and value is transpile expression packed, right? So we now have this in this value. So the value here is going to be the expression. Is this expression? This is expression, right? So we claim. So we claim the field of object, which is the identifier packed name, and field is member name member. Right? There we go. I think I have done it. All right. Okay, next. Next line 230. Pattern matching a reference. Yes, I do need to pattern match a reference sometimes. So how do we do this? This one is not that difficult, right? We don't care about the mutability, but we just have the referenced here. Right, referenced is a pattern, so we just need to pattern match the referenced with the pure place expression, which is a deref of a referenced. Yeah, I need to like deref this pure place expression, right? So this one over here is a reference, which we need to claim the reference and then deref it. Okay. Right, and in the does match of the reference, we have referenced. This is just going to be does match referenced with deref claim the current pure place expression. Okay. Next. Line 398. A native function. Wait, why am I transpiling the native function though? Where is this happening? What do we have in the native function? Do I have the span? Let's see what exactly function I'm trying to transpile. Oh, reflection type info. Is it because I have in the std reflection Because type info is a native function replacing type info, right? But like this doesn't actually exist on the target. Why is it done like this? So, and why does my JavaScript work then? Because we just say that the native function, it just has a to-do value name. I see. I mean, technically this should just be, you know, like there is no implementation of this type for JavaScript, only for the interpreter. But then what? I would have to like panic here. That is like compile time only. Well, I mean, is this compile time only actually? I mean, we could like do it in specific targets, I guess. Maybe that's what I do here, you know? We say that this is like type into... Let's do this. So this is going to be a function type into type info, which is C of G. Right, target name is interpreter. And then we have this. Then we call this native function, right? But in any other case, we're just going to panic. A reflection type info is comp time only or something, right? This should probably work. Exception variable. This is not inferred and cannot be awaited. Yeah, that's right. I should say true here. It's not underscore. This is a boolean. Okay, transpiler minicast line 405. So this is a compiler scope. We don't care about the compiler scope. This is going to be a unit. And T compiler scope is just an alias to the unit. No such file or directory. Source a mini syntax. Wait. I thought Nigel made the mini syntax to be read at compile time. But yeah, like, so okay, so actually, okay, so what happened here, what this means is that I have transpiled the hello world to the minicast, right? We have this file. Let's take a look at what we have generated. What is this monstrosity? So now we need to like write the transpiling from minicast to like next and like implement all of the missing features. Let's look here. So we have a bunch of types, which are unions, equal, greater, less. Yeah, okay. Maybe we don't need to generate this, but this is okay, right? But basically, we have the actual enum where every variant does not have any associated data, but we still generate the associated data type here, right? So yeah, right, like over here we have the data union, right? This is over here is the optional type, right? So in case of none, we have this. In case of this, we have that. Where this is a reference to any... Wait, what? Oh, this is like an option. An optional reference to any. Which is like somewhere in... Yeah, we have a bunch of options, I think. Here. There's a lot of types. Okay. All right, now the question is this even like correct cast code? Correct minicast code? That's a good question. So let's pretend that this is correct. Mini cast progress. Let's pretend that this is correct. I'm going to... Sure, I'm just going to push this. I'm going to copy the target compiled MKS into self-host temp compiled MKS, right? And we go to the minicast now. So here we should be able to have syntax highlighting to see if it is even like correct. This is a big file, right? It's going to take a while for it to be parsed, actually. The LSP is currently trying to parse this. Oh, wait, it actually does not have any errors? Also, what? Wait, what? Oh, wait, what is this? Context this, and then we have context this. Did I miss the new line or something? Yeah, I think I missed the new line for the contexts. So transpiler minicast, no, not transpiler, like minicast est. When I print the context over here, this forgot the new line, right? I need to say right line and then to print a right line, and before writing the line I need to write the semicolon here. Let's do it again. Missed semicolon after context definition. Okay, let's go back. Yeah, so now we have this context, and yeah, nice. Okay, maybe I should not be opening this file actually. How about we do this? Cast mini parse tests temp compiled MKS, right? Yeah, this is slow. Cannot finish parsing let. Unexpected torque in let. Over here. Oh, because we say like let arg is let this be that. Wait, what? Why would I generate this code? And what is this code? Let's see. We have a tuple. This is iterate. So this is... I'm not getting like the... like I got the semantic tokens here, right? But am I not supposed to get the error in the LSP, or that this is not expected? I don't have the diagnostics for some reason. Let me just try to understand what is this code. We have a consumer, so this is iteration over something. Loop block, and this over here is... oh, range iterate. Range dot iterate. With this consumer. We have reference to A. Wait, what is this? Reference to A? Hello? Something is wrong here, right? Can I just look over here in my code for reference to A? Is this what we're doing? For X in array list iter reference to A? No, that's not it, right? It's probably maybe this. When I have a loop over the reference to A. Yeah, from 0 to length of A. Maybe this is it? Maybe that's what I'm compiling. So we have a for. I mean, yeah, it is the for loop, right? Yeah, and it is the for over a range for sure. It's a for over a range. And this over here is the body of the loop. And the body of the loop contains the reference to A. First. Wait, hold on. Let first. Let first. Let first. Oh, it's this. First. Wait, why is this called first? What? This is F. This is me implementing the syntax. Why is this called first? Oh, because it's like the first argument, I think, was supposed to be, right? The first argument to the function. Okay. Sure. That makes sense. That's why it's called first. So we're piping something. Yeah, over here, I'm definitely piping something, right? Yep. So that's what I'm doing here. And then we like call this function with this thing, which is I. Yeah, I'm piping into I. And first is a reference to I. Why is it a reference to A over here? I'm just wondering. Like this A is what? Shouldn't this be just A? So, and what is A? A is this argument, right? Yes. I feel like this is the miscompilation of me doing the references. And over here, a let is also a little bit weird. So we have a range, right? This is a range from this, which is a constant, which is 0, right? So yeah, I'm pretty sure this is this code, right? So we go in range from 0 to the length of A. So this over here is the A reborrowed. I understand why. Right? This over here is the length function, which is called with this. Right? It's because, okay, it's because the expression, so we assign this to that. It's supposed to be the with parentheses here. Yeah, that makes sense. So I need to like insert some parentheses sometimes because my expressions in the custom minicast transpiler Right. I like, where should this be done though? Should I insert the parentheses if they are needed? There's also another thing. So right now we have the the AST can contain a then, which is like calculate the things and return the last expression. But then, like, if this is not surrounded with parentheses, then it is wrong, right? But I am generating this sometimes. Also, sometimes I'm generating thens with thens inside. So do I fix it when printing? It means when I'm printing expression, I need to know the priority of the expression that I'm printing, I think. And then I need to surround, like, I can also like surround every expression with parentheses technically. Or can I? Actually, no, I cannot do it with any expression. No. Not anymore. But in case, maybe I just surround the lets with the thing. I mean, yeah, we need to like make sure that the expressions are going to be parsed in the same way as they are here. Right? Fine, let's have the priority. Priority. Expression. Let's just call priority. Well, it's like parent priority, right? DP, parent priority. And priority is either like it's either the top level, which means any priority, right? Or I need to take like the priorities from the syntax, technically in the same order. Ideally, I like parse this actually and figure out the priorities of expressions that I'm generating to insert the parentheses properly. Right, because like in JavaScript, in generated JavaScript right now, I'm just doing the parentheses all the time. Not that easy. All right, hold on. I need to a bathroom break. All right. Going to fix the priorities of the generated stuff here. I don't know. Let's say any, and then let's say let. Let's see. So print expression also has BP, which is priority, right? Yeah, like over here, temp. This is still PP. If I have dref, then this should be dref. If we have the field, this should be the field. Current, this should be like current context. Okay. Well, field and dref have the same priority, right? So, yeah. And current context does not need to be a priority because there's just a name there. This should be like and or, I guess. No, this should be like and this should be like or. Because they have actually different priorities, right? What are the priorities? And is higher priority than or. That's correct. And or. Enum is. This is compare. Compare is higher priority than this. This is kind of similar to let. So let's say like, I mean, let's call this assign. How about that? When the loop, the body has any priority, when we have type ascribed, this should be ascribed, sure. When I have assign, and we say assign, and we say assign. Unwindable body has any priority. Unwind has unwind priority. Let has a sign, reference has a reference, object, dot, this is equal to that. That's also like a sign, I suppose. This has any statement. Statement. This is like cast. Any. If. And apply. This is technically same priority as the fields. The arguments though should have like any priority. Print function, definition body. Function. So over here we print this with the assigned priority, right? Okay. So I want more priorities, which is like a scribe function. Unwind. Statement cast. Ref and if. Okay, now we need to like make them in correct order. Function. If reference is before the fields. Ascribe is right before function. After assign. If is after function. Unwind. Unwind. Over here we have a token and I have the value. Actually, unwind, I have the with keyword now, right? Unwind this with value. That's what we do now. So technically unwind is pretty low here on the priority after if. Yeah. Statement is not higher priority though. Statement is really low. It's even before the assigning. Okay, I think this might be correct here. Okay, so now when we do what we do is that no. I need to like say what's the current priority is, right? Place expression priority pp expr, right? So here we always say cp. And over here we say cp is expression priority pp expr. So say cp 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 any. Yeah, it actually is like maybe it should not be cp here, but yeah. Wait, and what do I do? Like I compare the priority if it is no. Let's not do that. Let's just say maybe surround place expression pp expression, and this function is how we like actually print it. And maybe surround the expression pp expr like this, right? Well, we don't do maybe surround. Actually, we probably say surround is needs surround place expression pp expr, right? And then we do maybe surround surround, and it's surround expression. All right, let's see here. Needs surround expression pp expression expression. Hello, two-step. Am I using it to transpile to JavaScript? First, yes, and then Golang. But I have only like maybe finished transpiling from Kast to minicast. It's not that obvious, that easy to do that, it seems. So like I'm only finishing this and I'm still fixing it, and then we're going to fix the JavaScript transpilation, and then once the JavaScript is working through minicast, only then I'm going to work on the next compilation target of the minicast itself, which is going to be Golang. I'm pretty sure is the plan. So right now I am like generating the code, but I'm not surrounding everything with parentheses, and it is like done wrong. It's generating wrong code because of that. When I was generating JavaScript, I was surrounding everything with parentheses, but I don't want to do that here because parentheses, they do introduce scopes, and like the contexts are going to break. So I need to like properly surround with parentheses only if it's needed, kind of, I think. So we match expression. Here, this should return a boolean, right? So does the unit needs to be surrounded? No. Does it initialize? No. Does let needs to be surrounded? It means that parent. So how do we do this? Let needs to be surrounded if the parent priority is greater or equal to the let to assign, right? And stupid OCaml doesn't even understand that assign is this assign, which actually does not have any arguments. Stupid OCaml. Oh, because this maybe, oh, it's because like this is the type actually. No, never mind. If I do this, then it's going to know it. Is Golang a nice fit for bootstrapping compiler? I don't think I would want to write the code in Golang by hand, but there's a lot of people who like it, so I don't know. Decide for yourself, all right? I think as much as I hate OCaml, Golang is much worse for me. But I mean, like I don't know, like people like different kinds of suffering, right? Some people like writing code in C. Like I don't understand that either. If I was to choose between C and Golang, I would probably go for Golang. Why Golang for game dev? No, it's because of the runtime. I just want to like I'm just lazy, so I want to do the least amount of work when I'm working on my language, right? Which is why JavaScript was the first target, because I don't need to transpile the types and everything, right? Like we already type checked the program. Why need to do this? Why do we need to do this twice, right? And in order to go for the lower level targets, there is a lot more work needed to be done for the lowering and stuff. So JavaScript is high level and untyped, and it makes it very easy to transpile into. Golang is similar to that, where I don't need to to do too low level, to do too much lowering either for the transformations, right? Because Golang is still pretty high level, and technically Golang still has some of these like dynamically typed things, like the empty interface and things, which I am going to be using. Golang still has lambdas. It has garbage collector, so I don't need to worry about the memory safety yet. Right? So, yeah. um, yeah. And also like the runtime, the Go routine runtime, that is the important part for me too, right? Because right now the performance issues with my JavaScript is that I'm abusing async in JavaScript, right? But in Golang, everything is already async implicitly, but it is still a fast language because the runtime is just done a lot differently than in JavaScript. So I don't need to do much, and it's just going to work 1,000 times faster. Golang might be a nice fit for a functional language like Kast. I don't like when people call Kast a functional language. I don't understand why do you think that, actually. We just use Go as the runtime. This is like kind of wrong. I mean, what does it mean for any language to be a nice fit for a functional language? What does that even mean? Wait, do we have unwind? Like eventually we don't want the Golang anyway, right? Like in the far, like if we go directly to the final destination, then we don't do JavaScript, we don't do Golang, we don't do C transpiler, we use like directly like LLVM or whatever. There probably should be like some alternative to LLVM for the like compile time reasons, but you know, for the performance, maximum performance, we want to go to LLVM eventually, right? So we definitely don't want Golang. But for now, for simplicity, yes. Hmm. All right, let's see here. Maybe surround, surround and f is, we are going to call f, right? But then we say that if surround, then we're going to write an opening parenthesis, write line, and increase indentation, right? And then after this, we also say that if we did surround, then I'm going to decrease indentation. Right. Yeah, we just decrease indentation. Do I still want to write line? Probably, right? Decrease indentation, write line, and write the closing bracket like this. Okay, let's try again. LVM is probably not going to happen very soon. Maybe like I don't, yeah, like not very soon. At least 1 year in the future. Maybe more than that. Maybe LLVM could be done by someone else, actually. But we'll see. Okay. Let's see the code. Is this better code now? What is this? Oh, we say like unwind this with that. Unwind loop block with this. Shouldn't this be an identifier? Yeah, which is why this is not compiled. I mean, at the same time, it's because I need to restart the language server because I changed the syntax, right? But why do I say unwind loop block over here with this being in parentheses? This should not be in parentheses. And is unwind... Unwind does not have a big priority, but it is bigger priority than inif. Wait, what's wrong here? Parse. Unexpected token if. We cannot finish unwind like that. Oh, wait. I think it means that it is because I actually read the syntax at compile time, right? So I actually need to rebuild here. Okay. Let's rebuild and let's figure out why unwind. The token. Oh, the token is an expression, right? If this is an expression, then yeah, then it's okay. But if the token here is just a simple expression, which is me claiming the place, which is identified, I should not surround it with parentheses, right? I thought. Unwind loop block with this. Yeah, this is weird, right? Because loop block, this is just a reference to the variable that I'm supposed to not surround. Right, like according to this code, it should be false. But it is true somehow. Alright, let's try parsing this again though. I mean, it's going to be parsed, but... I mean, this specific example. There's also like this, reference to reference I. This is a little bit weird. Because I definitely don't have the devil references anywhere, do I? Wait, and this still... Yeah, and this like... Wait, what? Wait, hold on. Why does this not parse though? Unwind with... Unexpected token with. Can finish parsing, unwind this. What's my syntax? So the token is more than 1,000, but that doesn't really matter. Right, I do have the with keyword here. Let's try to do this. Kast mini parse, but let's just say this. Echo unwind A with B, right? Like that. And this doesn't work because it says unexpected token with. This is wrong. What if I say unwind AB? That also doesn't work. So for some reason it's not doing the with. Oh, because it is in the... is that because it's in the continuation keywords? There's no way. No. Is my parser incorrect? Kast parse, right? Like this over here is going to not do that. Oh wait, did I change the syntax? No, this is the mini syntax, right? Wait, why is this saying cannot finish parsing with underscore? Right, because I have with context type is equal to that. So like it's trying to, yeah, because this is higher priority. That's right. Wait, no? That's not right. Oh, yes. I'm trying to parse the syntax rule set source mini syntax. There we go. Okay. Cannot finish parsing unwind. Because it says unexpected token with, even although there's obviously the with that can happen after that, right? Should I look into my parser? What if I change in my main cast, right? So like, let's do here, cast parse, unwind A, B. So like, right now we don't use the with keyword, and this is being parsed, right? If I say the with here, this is going to like error out, of course. Right? It says unexpected end of file. So, but if I change the default syntax rules where unwind actually requires the with keyword here, then this parses, right? So like my old parser works, but my new parser doesn't work. Okay. So there is a bug actually in the self-hosted parser, it seems. It seems that there is a bug. It says unwind underscore 1 to 110. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So like this is literally what we have parsed. And I have parsed unwind followed by a value, which then expects to the keyword potentially, but it for some reason is not following with the keyword. Okay, fine. Let's take a look at the parser. We want unwind. We want what do I want? I want this, right? Try parse single rule node. Not following because it's a continuation keyword. Like this, if this is so, if it's because I'm not following because it's a continuation keyword, that would be weird. But it doesn't matter because I have made progress. So I don't even care about that. Because I can continue here. So it's syntax rule priority matches. Oh, wait, is it the priority matches? Hold on, edge, max rule priority. Matches the priority filter. If I have a keyword. Yeah, no, I think that is correct, right? Yeah. And max rule priority is actually none, so like this should always be true. So I stopped over here for some reason. Because I could not follow with a keyword or with a value. Let's do the info. Here, it's just going to be very slow to debug. Let's not do this. Let's instead go to the log and say that the minimum level is like debug, right? There we go. I will see all the logs that we have when parsing this thing. With is not being consumed, right? Like, but the question is why, right? So I have like, and it works in the Bootstrap parser, but it doesn't work in this parser for some reason, right? So here's what we're happening at, right? Oh wait, I'm looking at end of file. Wait, what? Oh, I cannot finish parsing with here. Yes. It's not the unwind that cannot be parsed, but the with, actually, which is a different error, right? So the question is, right? So I'm parsing unwind over here. Okay, let's see. So here's what we're doing, right? First, we're looking at unwind in the first token. Then we're following with the keyword unwind, right? Then we're looking at A, which is not a keyword. So we have parsed a single token A. We made progress. We're looking at with. A with is like not the thing that we should start parsing, right? So we have done parsing this single token. We're not extending it into like a child AST. So we are doing like unwind underscore now, right? We're looking at with. It seems like parsing while parsing, like this is in the different order or something. Yeah, so we're looking at with while parsing unwind underscore, right? And then it says try parse. And I think that is wrong. Try parse means that I'm trying to parse inner value. Well, I mean, hold on. No, right? Because I'm doing the parse, right? I want the rule set source syntax, source mini syntax. There we go. No, yeah, because this says I cannot finish parsing the unwind. I was once again looking at the different syntax parser. Okay, so yeah, this one is a lot shorter, right? We just go into unwind. We're following with the unwind. We have made progress. We're looking at with while parsing. Wait, why is continuation keywords is with a space? Wait, did I put a space there? There is no way. Did I put a space here? I did. Oh no, that's why it is not being parsed. Because I put the space here. Look at this. It's because like this syntax highlighting is not very good, right? There's a lot of quotes, right? So, and like we basically have a keyword which contains a space inside, which obviously should not be like is not the case. I think there is no bug. There we go. Okay. There is actually no bug. I just defined my syntax incorrectly. Maybe like in this over here in the syntax highlighting, it should like underscore or have a background for all of the like strings, right? Yeah, I think that would be nice. Is there like a semantic token which because I'm doing the highlighting with semantic tokens, which has a background to it? Like I'm using the one darker VS Code GitHub. I don't know how to look at the source otherwise. One dark pro extension is what I want to look at the source code of. Right? Like, is there anything that's highlighted with a background? That's my question. It's like hover background. Nothing about like the tokens, I think. Yeah, so like I need to either customize the theme to have the background or something. I mean, I think in general, having your string tokens be having a background is nice, maybe? I don't know. I don't want to work on that right now then, if it requires this stuff. All right, let's see if the compiled file is parsing at least, right? Unexpected token equal over here, right? Because yes, we actually need to have the equality. This is where the tag, this pattern matching, some versus none, right? We need to compare the tags. In general, I don't want the operators in minicast, but the comparison should be here. And it should be somewhere over here. Syntax equal, I guess. 15 wrap never is underscore equal underscore. Okay, it seems like I've parsed it. I don't think I want to be printing that though. Like this. So it seems like it is at least parsing the code. So next thing that I want to do is to actually compile it. And this is going to give me the compilation error. Somewhere it says over here, unexpected top level item, right? Because this is just a constant of type unit. Yes. Wait, and why is this like that? This is a type. If this is a... Shouldn't I have... Oh, it's because this is a type, right? Yeah, because these are aliases. Aliases to existing types. Right. So for these, I think want the type keyword, because that's how we do the alias to a type. So let's see. This is when I'm printing my program. If I am going over all of the types, right? If it is an alias, I don't just print the type, because before I'm printing the type, I should write type space like this. Okay, so yeah, see, now I have the type everywhere, which makes all of these to be type aliases. And we have a billion types, okay. So type, we don't have it, so let's introduce it. It is somewhere, yeah, I think the type should be like somewhere high up here. Syntax type alias, right? Which is 3.5. Wait, why does minicast syntax has the unpacks? They should be removed. We should clean this up. There is a lot of things that are unnecessary, right? Like instantiating the generics and things. So we just say type space underscore. And then in the minicast mini compiler, if this over here, this is the top level item, so if rule name is equal to type alias, is that what I called it? Type alias. Then we have type definition name alias. root. Return. Type definition. Type kind. Definition. This actually doesn't have the record, so no. We do it a little bit differently, right? Here, more like this. Item kind is type alias. And definition is root AST helpers unwrap expect single child with no name. And type kind should be an alias too. Right? So if I have the alias, then we just add definition, which is alias, which is parse type definition, right? Is that what I want? Unexpected top level item over here, the contexts, right? So like we need to implement the contexts now too. I'm like I have parsed like half of this file actually, right? But this is just, yeah, I have parsed all of the type definitions I see, right? I've parsed all the type definitions. Now we have the contexts, and then we have the function, which is main, and and then we wait. What is main the only function? No, there's no way. To string print parse this. Oh, this is me like using this std prelude. Yeah. So this is all the things that we have in the prelude, and then we actually call the print over here. F is this value, which is this const, which why is this a reference? Oh, which is a reference which I dereference immediately. Oh, I see. Okay, so this function is value, which is this. And this looks incorrect syntax, by the way. What is this? This is me initializing a constant object. All right, it means that I am not printing the expression object, right? Yeah, because I am saying dot field is equal to value, but then I need to also write the comma and right line here. There we go. That was forgotten. Let's go to the just file here, maybe. Just minicast. Right. Yeah, I'm doing node like this. I want you to like run this code basically in the other directory. Self-host, because I'm parsing this index at runtime and this doesn't make it available here, right? Do I just say over here like push the cell let how do you get the full path? Is there a full path? Base name? It's not the base name, right? Yeah, no. How do you resolve the path? Resolve full path bash. Real path. Real path target. Okay, there we go. Compiled. MKS. Let's do this. MKS is a real path target slash compiled MKS, right? So because like now we don't care about in which directory we exist, and we can just say, and then we can say MJS is compiled MJS, which I'm going to run over here. This is like MJS. This over here is MJS. This is the MKS. And this over here can be yeah, we're just gonna like push the dot self host, and we pop d then, right? So then we can like do the minicast MKS unbound variable. Do I need to export it, or do I need to say usr bin and bash here, because otherwise you cannot do the variables in just? Right? So yeah, there we go. I'm compiling to minicast, then I'm over here invoking right now the minicast compiler, which is going to say that unexpected identifier error. Wait, what? Why is this over here printed? And why is the error like it's like I'm trying to run the MKS. Oh, we have compiler error. And then the unexpected identifier error. Right. Oh, yeah, okay, I see. It's because I'm printing the error to the std out or something in my over here, right? Yeah, it's trying to compile the compilation error because I think I am like let's do this cast mini, and then would I like say echo ASD like this, right? So this is going to say cast mini. Oh, I do need a path. All right. Let's say cast mini, something like flake nix, right? So this is, oh shit, I need an actually MKS extension. I'm checking this for some reason. Okay. Let's just have a syntax error over here, right? And then we say cast mini tests, mini test like this, right? So this returns the error, but I think that this is just being printed into the, well, I mean, wait, hold on. I am exiting with this, right? But basically, if I say dev null, then I don't see anything, right? Which means that it's being printed into the std out instead of std error. Yes, that's exactly what it is. I guess I can fix that. It's somewhere like maybe in main. It's probably in the diagnostic default handler, right? Yeah, because like it's just printing to the output, which is the current output, but it should instead print to the current std error, not to the output. Right. There we go. I think that's all that I need. And also in this, like technically this returns with exit code, so I need, since I'm doing that, and to set dash e, right, so that it stops on the error. Supercuber, by the way, how are you? This compile times is paying 42 seconds. All right. We will ignore it for now. I think before like the full self-hosting, I will try though to improve my compile times. Otherwise, it will just be very annoying. Procrastinating work, the usual. Yeah, I see. So yeah, compiler error at colon. Wait, what is this? What is this error? This is wrong. Oh, wait. Okay, hold on. This is not correct. I need to say current output, and I need to say that, with output being current std error, right? Because over here, when I'm printing something like spend print, it's printed to the std out still. And this needs to be in parentheses for some reason. Whatever. Compile times inspired by Rust? Yeah, exactly. But we are slow for different reasons. Because I am actually trying to not monomorphize, which is supposed to help with compilation times. But it's just the other things that I do, which can be fixed. Like, I think that if implemented correctly, it should all compile very, very quickly. I just need to implement it correctly now. Okay, compiler error over here, right? This is an unexpected top level item because this is the context system, which is not implemented in the minicast yet. So let's do that. Minicast. Right, so we are supposed to have the context system in minicast. Let's do this. So this over here right now is actually compiling, right? Just cast mini tests, mini test like this. Right, this is actually no, it's not compiling. It's expecting this to be a scope. Wait, what? It's because my functions are not... Oh, maybe I need like this over here. No? Type is not found. Okay, yeah, we ignore this though anyway. Let's forget about this. This is like some old test code that I was doing. Parse is not found in current scope. Let's not parse, right? What I want is to have the context system. So we want to say that const context is context of type, let's say type int32. It doesn't matter, right? So over here we say like with context being 1, 2, 3, which we must do a native for now. And is native having a different priority? Weird. I need to fix my priorities here, I think. And then we say like print to string current context, right? Like this. Let's try that for now. So now it says unexpected top level item. So we have top level kind is going to be a context. Right? So we are going to say that if this is, and what is it called? Create, it's called create context type, sure. The definition is going to be the, not the value, but the root ast helpers expect single child named type, it seems, right? So we have top level items like this. Let's see. So my program should have not only types, constants, and functions, but also contexts, which is just a map from string to context. Well, I mean, the context just have the type, so it is literally just a type here, right? Yeah, I think this literally is just a type. So we start with context being empty map here. Then we say so first we process the type names. So I already know all of the type names. Right. Process function. Yeah. Pre-process function. Type and function. let's say over here that if we have the context, then I'm just going to say that state program context map add item name, and this is going to be like just parse type item definition, right? I think that's all that is needed here. So now when I am, yeah, and then we also have the current context, and this is the place expression, parse place expression, which is parse expression impl here, right? So I should say that if we are trying to get the current context, right, then then context name is just expect single child here, and then we say is helpers expect identifier, so we know the context name now, right? And then I'm going to say that context type, so the type of this is context type, and this is going to be a place expression, which is current context of context name. I just need to like figure out the type, right? So this is going to be match to have context here. Context program contexts get context name, right? So if it is found and we have the actual type, then we will return this type, but if it is none, then I need to like diagnostic error saying that unknown context string context name. All right, let's try building this and running. Well, I mean, this is just the like the intermittent presentation now, and it doesn't compile. Okay, why? Because current context is not present in over here, right? We need to have a place expression, which is the current context. of this name, right? There we go. Okay. I can improve the compile times by doing the continuous compilation a little bit, but I probably will need to give it more RAM. Let me take a look at what my current RAM is like. I'm only using 12 gigs out of 30, so maybe I can give it like 5 more gigs easily. All right, and then we say over here context expect a function. Wait, what? Why does it expect a function? Why do you expect a function here? That makes no sense. All right, let me give them 10 gigabytes. It expected fun asserted fn. There is no expected fn, right? Oh, it's just expect rule fn over here, right? It seems like because I pre-process it as a function, create context type. Yeah, because create context type is like over here. It's not a function, right? It should be context. There we go. Because I copied it and didn't change this thing. All right, so we just do build continuous, and then it's going to be better in incremental compile times. All right, so Kast mini. Let's try again. Okay, so now we have the non-exhaustive pattern matching over here. Nah, this is in the very beginning. Type. Yeah, it's because like, yeah, over here. Yeah, we just do the type names here. We do the type names first, then we process the top level functions to figure out their types. The context, then we do the type definitions, then we constants, and then we process the functions. Okay. Let's recompile. Let's see what's the incremental compile time here going to be. Probably just 10 seconds. I'm using 5 gigs here. Okay, expected an expression got with context is native 1 to 3, right? So like this is actually not the correct expression because we need to parse it, right? So this is called inject context. It has context type and value. So if rule name is equal to inject context, then we say that context name and value is root is the helpers expect expect two children named context type and value, and then context name. Let's call this context name AST. So this is going to be context name AST, expect identifier, right? So we're going to also find the context name, right? Yeah, so context type is actually going to be like find context type of context name using context name context type. Let's do this, you know, like name and yeah, let's do this. Context name and context type is parse context type context whatever context type. Yeah, how about this? And over here we do the same thing. I deleted the code. Can I undelete the code? So over here, just return. So this is going to be an expression. The type of this is going to be unit. Right, but this expression is inject context, right, where we have context name and value is parse expression of type some context type, and this is the value. There we go. I think that's what I do. So that we will have another function called what did I call it? Parse context type, right? Yeah. So this is going to be like AST, and this returns the string, which is the name, and the type, which is the type of the context, right? So context is current context. Then we do all of that. And I just return context name and context type like this. Hello Zend. We are making a little bit of a progress, yes. I suppose. So yeah, I need to introduce the thing called inject context expression. Inject context name string value expression. Okay. I'm right now implementing the context system in the minicast. Hello, Nerdcell. ToString not found in the current scope. Wait, do I not have ToString? Oh, we have int32 ToString. Okay, and then we have what is this? Error has named fields. Huh? This is the panic. Oh, we are trying to unwrap unnamed impulse. Unwrap unnamed. One. Children. When we do expect a single child. It's like you're watching a different person because the camera view changed. Do you think it's better or worse? Because my hand is always here, right? When I'm thinking, covering my face. The lighting is worse. What if I... I think like lighting is something that maybe I can configure on the camera though. Like it's doing some automatic stuff. It's because this over here is light and it's like trying to like darken everything else because the window is too bright. Yeah. Hold on, can I fix the camera though? What do we do?
He's so tall now.
White balance automatic. Uncheck. 1, 2, 3. White balance temperature. Ah! Why is everything blue now? What is the temperature that we want? Sharpness, backlight compensation. 1, 0. Exposure. Tilt, focus, zoom, saturation. Brightness. Well, what is the settings that we want? Do you want all the saturation here? I don't know. I feel like I have messed with the settings now, and the fact that there is no canceling here is a little annoying, I guess, but I don't know. I don't know. Did they make it worse? Wait, hold on. It is still like changing the lighting automatically, right? When I'm covering the window. Didn't I uncheck the automatic stuff? Okay, whatever. The only cool game with lighting is Flash Dark. And you made it? Wait, what? You made my game? I don't remember you making the Flash Dark. Did you make the lighting there? Oh, wait, what? I don't remember that. Did you? Okay, is it because of the type alias?
Hello bad cop underscore.
Type alias does have the unnamed one, right? Okay. Next, what did we do? We had create context type, which has a single child with this. Current context. This is the one that doesn't work because this needs to have the name, right? And the name is current context. Hello, Badcop. Called context type. Your dog Plushie has a hole. He's slowly losing his stuffing. He needs to do surgery. Oh, who made the hole? What did you do to your dog? All right, now we have pattern matches non-exhaustive over here, right? So this, I think we have like basically like done the processing of the minicast, and now we are trying to transpile this to JavaScript. So JavaScript needs to have the expression, which is we need to have like the inject context here. Hello, Athano. Inject context, name, and value. Right? So this is going to be something, and then we also need to have the well, we just have inject context and current context. The context type we don't care about. He's an awesome pig. He's getting thinny. Who, your dog? All right, so when we inject the context, we just literally need to say that we need to have the context, the scope, right? We need to override this scope here with a new scope. The block is still going to be the one from the current scope. Current scope block, but the context variable is going to be a new context variable, right? So I will say that context var is generate name in new var context, and then we say like let var. Do you have a let var? Yeah, we do have let var context var being equal to, so I need to create a new thing, which is an object which has the parts array list new pushback. So I need a part which is unpack, and I'm going to unpack the current context, which is var current scope context var, right? Because we basically extend the current context variable by adding a new field with name and value, right? And value is just calculate, just I guess var calculate value, right? Because this is an expression which we need to calculate and stuff. Yeah, and then we like override the thing. Wait, we don't do with scope, right? I need to actually mutate my current scope. Right? Yeah, I just need to instead say that current scope context var is this new context var. All right, and then when we calculate place, if this is the current context name, then what I need to do is I need to have the place of field, name in the other place, which is a place of a var, which is current scope context var. Okay, there we go. So in the current context variable, we get the name field, and that's, I think, all that we need to do. Recompile. It does not recompile. Right, so this should, and this just returns the, the value is just null. Yeah, whatever. What's this indie band cover style, camera angle? I know. I just moved the camera there because there's like sun that is shining through the window. Well, not right now, but like earlier. Not anymore. And like when my camera is in the usual spot, then the sun just shines directly into the camera, and like then you don't see anything. Do you not like this? I heard there is like multiple successful streamers which are streaming with this camera angle. So like, that's a nice flower. Right. You could see it in the other angle too, though, I'm pretty sure. Flower cam then. And a longer cable, I think, for my second camera to be right on the flower. Okay, here we go. JavaScript here, cast color falls into node, right? Okay, so what we're doing here in this code is we are like having the context, which is 1, 2, 3, and then we like printing it directly here, right? Also, if I do this inside of this scope, and then I'm having this scope like, so this like outside, and this like inside, and I'm going to print the current context here, and then I'm going to print it here, right? So this means that I'm going to, outside is not defined. Oh, yes, because, yes, let's say context, which is a string, you know, that's going to be easier. And we don't do the interrogative string here. We just print the current context, which we say the context is outside or inside. Right, there we go. So we have outside, inside, inside. Actually, hold on. This is a bug. Wait, why is this is a bug? This is a bug because like over here we have a scope, and it should actually, yeah, it should print outside over here. JavaScript. No, it's minicast. Ignore the JavaScript. It's because when I'm calculating the scope over here, right, I'm just calculating the inner expression, but I need to make sure that I don't override the context variable here, which means that I need to calculate this, but I need to do it with scope being equal to well, we can just like say current scope. We just need to make sure that when I mutate this object, we don't mutate the original scope here. So when like we inject the context, it doesn't actually affect this thing. Okay, there we go. Outside, inside, outside. Now this is the correct output. Okay, so this is mini cast contexts, right? Now let's try to do this. Well, not that, right? I'm trying to like compile to minicast and then process that. So let's see what is the next thing that needs to be done. Type any is not found. Oh, that's probably like that's going to happen, right? Yeah, type any is not found. So what is the type any? We need to have the any type as a built-in. I'm thinking minicast. Right. So if it is any, then it should be any. And I think any should not be lowercase but uppercase like every other type. Minicast AST. It should be capitalized any. So we have the any type. It's not, but the any type type checking is different, right? So is there like a type check? Yeah, we do have a type check, expected and actual, right? So we say that if we we resolve type aliases. So if any of these is equal to any, then it's okay, right? Yeah. So it's not like about structurally equal anymore. We need to actually recursively go into the types and like check the anything, the any types, right? Yeah. Let's first see the compilation error where we don't type check the any type though. Well, I can also like have the conversion to the any type to be explicit, right? It's like and not have any implicit conversions, even if the type is any. Not sure. Expected a type got a reference. Yeah, and then we also don't have the reference types. So I need to have a reference to a type, right? So if rule name is just called ref, right? Okay. That referenced is root expect single child with no name. So I return a reference to parse type referenced, right? It's 7 gigabytes, okay. Expected type got list any. Okay, so we also need the lists. And I think so the lists, I think, in the yeah, we should not have like instantiation of the generics, right? But I should have a dedicated list type, right? So this should be like a list. And this is, instead of generic, is going to have the list arg, yeah, which I think we just do this list arg any closing thing like this. List element underscore, just underscore, yes, okay. So we're going to do the same. If this is a list, then element, and then just a list. And we just have the list type. Load 64 is not found. Wait, what? Did I not do it here? Yeah, I need more types. In 32, in 64, bool string, in 64, float 64, bool char string. That's what we want. Char in 64, float 64. Expect expression got a struct. Okay. So yeah, this over here is me constructing an object, right? So this is the this looks like a prelude of standard library. So I want to be able to parse the objects. Okay. Bum, 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 bum. It's called record here, right? Yeah. Okay, so we say parse expression. Over here, right? So if rule name is record, right? Then okay. All right. So we need to kind of know the expected type here, right? Because it should be inferred in this case, right? So if let type be expected type with some type, then type none, then we do the diagnostic. Type of record must be couldn't figure out struct, like figure out the type of this record, right? Something like this. This is just a span. Okay, so we need to know the type here. Now this type is a type. And since this is a record, it must be a named type, right? Right. So we say that let. So like it should be like either a union or a struct technically. So we do the unions in the same with the same syntax, where we just initialize a one field, but in the struct we must initialize all the fields, right? Yeah. So I need to know the type definition, right? So type definition is match. We need to just like this, you know, like fields basically and is a union, like and like kind, you know, where kind is either a union or struct here, right? That's like the only things that we want to support here. And this thing, right? So field is going to be the map from string into the type, and the kind is this kind, right? So over here we're going to match type, right? So if this is named type with a name, then we need to find the definition, which is context context program types get name unwrap, right? Over here we can unwrap because this is coming from the expected type. It's never supposed to panic. So then we say that, yeah, if it's not named, by the way, then we should just say that it is like not the one, right? How about we like just going through like return here. So we're going to match, and if we did not like do something, then we're going to throw the error where we're going to say that this so this type cannot be used as record, right? And over here we say print type name of the type, right? So here we have the name, right? Now the definition, type definition, right? It must be a union or a struct, basically. Well, it should. We should also like resolve the aliases here, technically, right? Resolve type aliases of the type. Now, after I resolve this, it must be a named one, which name, right? So we say like we're going to match definition, right? And if this is struct fields, that this is what we're going to say, fields fields, yeah. So like over here we return fields struct fields, maybe. Let's have the kind of the first thing. If this is a union variance, and this is going to be the union variance. Anything else? We just don't do anything. So now that I have the kind and fields, right, now we can actually parse the record itself. So the type here is going to be the type. The shape here of the expression is going to be the record, I guess. And the record is going to have the fields. Right. Right. A record is going to just have the fields. Fields. New array list. So we let's first specify the expression. Right? It's going to be an expression which is a record, which has a list of fields. Right? And field just has name and value, which is expression. So now we need to like iterate over the root ist helpers expect single child with no name, and then we say ast iterate list for field in the stuff. Do this stuff. We iterate list. Can you format? Yeah, we iterate list where the binary. Oh, wait, yeah, and I cannot do that, right? Yeah, I need to like AST iterate list here anyway. With this as the first argument. You started in JavaScript backend to your language as well. Nice. Now people are going to hate you too, because people hate JavaScript. Okay. Root. So we have binary rule name, which is a comma. And we have trailing or legendary rule name, which is trailing comma. You're already in the JavaScript ecosystem, so you're fine with that. All right. So we are doing this loop. Now every loop here, right? Now yes, now we do this. Now we say field is the helpers. We want to expect the rule to be called. Let's see. So we have like commas, and then inside of the commas we have the field init. Field init, and then we expect 2 children with names, name and value, right? So that's going to be name and value. All right, then we're going to say that name is name expect identifier. Okay. So now we have the name. I have the fields. I call these fields too. Let's call this field types, you know? So, yeah. Basically, we want to say that field type is field types. I want to get from the field types the name. Right? So if it exists, Then we just return that. Right? But if it doesn't exist, then I need to also print the error saying that, so the span is going to be what? The field span? Maybe not the field, maybe like the name AST. And then we say that type doesn't have field string escape name. Right, so we say that the type doesn't have this field. There should be a match. So now we know the field type, and we need to parse the value, right? So value is parse expression, which has the type of the field type. And next, we need to say that fields push back the field with name and value, right? Like this. And then we need to like understand how many fields have I seen, right? So because we need to make sure that all of the fields are initialized, or like exactly one field initialized for the union, I guess. Right? That mode fields initialized is stored set new, right? So when I initialize here, I'm going to say fields initialized. We need to add there the name, right? But if it contains the name, wait, what do we have in the org set? Let me take a look. We have contains, we have add, and we don't have remove. How about I add remove here? Remove t self org set t x t. Should also return the boolean whether it was removed or not, or something, right? Org map remove x self inner self inner remove x option is some, right? Reference is not okay. Yeah, because is some takes a reference to an option. Let's just match here with non false. Some true. And like the value is a unit there always, so yeah. That was as is use std collections ord set. A is ord set new. A ord set add A. A ord set remove B is going to be false. A ord set remove A is going to be true. Then if I do it again, it's going to be false. Okay, I think this is basically working. Ord set remove. Okay. I changed the branch version, by the way. I think this should be Kast, lang, Kast, bootstrap, or camel. That's what we depend on here. So this is me like type, yeah, I did not do it all yet, right? So we want field initialized or set add name. But what if it was already added there, right? Or set add. It doesn't return anything, right? So we just should say that if it was containing it before. So right. So if fields initialized contains the name, then we are going to say that it was already initialized. Is present multiple times. I could like show the previous one actually easily, like we have this related information if I wanted, but then I need to like remember it. Fields initialized. So this is going to be like actually an org map after all, right? Field initialized. Yeah, it's going to be a map. And I'm going to add to the name the span of it. So it's like name AST span basically. That's what I want. Right, so then I say fields initialized ord map get name, and if this is some other span. SR messages probably aren't as important in minicast. Yeah, but like also it's kind of easy here to make this error messages a little better. I mean, I don't know. Like maybe someone will want to write the minicast for some reason directly. Like I imagine minicast like is going to be like considered finished a lot sooner than the cast itself is going to be considered finished, you know? So I don't know. It's not that difficult, right? We're just going to say over here, we say like this field this has already been initialized, right? And we will say that it was previously initialized over here in the related information, right? I should really have like syntax sugar for creating the list with a single element, or like, I mean, even like just having string literals or something. Yeah, whatever. For now though, we don't care. Maybe. So what's the related though? It is in the error. It is in the diagnostic, right? We have the related info. It's just span and message, right? Yeah. Info. So info is span is this is like other span, right? And message is a function which says this, right? Previous, we just say previous in the previously field was initialized here, right? Like this message. Does Kast have affine types? Not yet, but yes, it's supposed to. I also want to have linear types, not only affine types. Not sure about like the other things yet. Right, but like people in Rust, they also want ordered types, whatever that means. You want stable memory locations, right? So affine types give you no more use after free. Linear types means that there is no more memory leaks. I'm not sure if that's true, but well, I mean, yeah, if you don't like give you the escape hat, if the escapes, right? Like if you cannot mem forget the linear type, I guess. There was a whole 3D grid of those. Yeah, there was like, I'm not sure like if the order types though is like about this thing though that was in that grid. They say exactly once in order. One step beyond linear types is the order types. These types aren't just used exactly once, they are used exactly once in the exact order they were introduced. That means that in practice, there are types with a stable memory address that will never be changed until they are dropped. But I mean, like, the question is, if it's exactly once, then, like, if it's exactly once, then what do you mean, like, they are dropped in order? Like, because, like, there's only one place when there's dropped, or, like, is it ordered compared to the other type? Is that what it means? Not sure. But yeah, there's, like, more stuff, linear, affine types, like, grid, or I don't know, it's not a grid. Yeah, there's like this linear, affine, relevant, and unlimited, right? But there is more than that. There is more than that. So like relevant is the type that is used at least once, which is basically the must use attribute in Rust. But that's not on the type, but on the variable instead. We want it to be on the type, right? Um, Unlimited. Yeah, there's like more things that you can do. But like right now, I don't do any of that. Right now, I don't. I don't. Yeah, right now I don't, but it's planned. Okay, I just need to fix the other things first. Like I think that calling the like I want the Rai for sure. I guess I have kind of not really needed that so far in making the language. Oh, we have a name thing called variants, and we have a name thing called fields. With linear types, you can return them by value before they die, and that requires changing memory location. Yes. But I'm not sure why they call it the order type then. Like, isn't, especially in Rust, the things that don't change the memory location are supposed to be the pinned types? What is this? Cannot be used as a record. Type this can be used as a record, right? So this is this is just AST span, I guess here. It's formalization of pin types. Yeah, maybe, I don't know. They already have the error. Return parse if. Right, because this is supposed to be the expression record with fields. Okay, it looks like it's compiling. It's not going to be... let's have a test for it. Mini test over here, right? So we want to create a type, foo, which is a struct, right? With field A, which is an int, and field B, which is a string, right? And we also want to have the file U union, right? A is string and B is unit. Let's try that, right? So I want to say that let's foo, which is foo, which is going to be a struct with A equal to 1, B equal to 2, and then we say that U is U, which must be like B is unit, right? So like in this, yeah, let's see what's happening. Cast mini test, cast mini test. All right. Tuple doesn't have field name. Field in it. Oh, it's called label, not name, of course. Foo doesn't have field F. Okay, actually, oh, it's because like this foo and this foo is different. Yeah, I have like the same type done twice. Let's call this S. I think I should like panic if the type has already been defined, right? Like that is not something that I want to support. Pattern match is not exhaustive. Okay, so this is where I'm like doing the JavaScript now. Yeah. Yeah. Let's do the JavaScript record with fields. Then we just say that we return an object with JS fields, right? And JS fields is this for field in fields array less than 2 insert do. We have JS fields. Oh, this is like the parts of the object because we have like the spread operator, but we don't use the spread operator. We don't support the spread operator in minikast. So all of these is just going to be a field with a name. Name is field name and value is calculate field value. I think that's what we're doing. Okay, actually, you know what? Let's do this immediately, like the duplication of things. Like, same goes for the functions. The functions should not be duplicated, right? We just say that, but then I need to, yeah, and then I need to know where they were defined previously. Right, because I just have the function types, type names, and like, yeah. Do we want to like not have the top level, maybe like top level items in general should not be duplicated, you know? Yeah, let's not have like the same name for the type and function and the things, because that would be confusing, right? Maybe. And we don't support that in the regular Kast because everything is a value anyway. Add source est. Yeah, like let's say that we just have like top level item definition span. You know, how about this? So there's going to be an ord map from string from the name to this. Top level item definition span is ord map new. So we have the top level item. Right? We have name and value. So over here, we say that ord map if. Do we have context here? State. Yeah, we just have state here directly, right? So if state top level item definition span get name. Well, they're also like type ascribed, right, and stuff. But then we have this if. This makes it a constant because this is like type ascribed here. Okay. Let's do like over here, right? After I get the name, right? Check. Okay, add name, add top level. Set top level name. Set top level definition of name to be equal to add top level item, right? Yeah, I feel like I would just want the name ASTs here. To the beam name AST span. Discard not have auto dereferencing. Yes, I don't have the auto dereferencing yet. I'm not sure how we will have it, but I think I will, but I'm not sure yet. Like it is, yeah, it is important, but like, yeah, it's okay for now. A little bit verbose, but whatever. That's top level definition of name to be span, right? So this is going to say that if state we considered full reference types like Odin. Do you think it makes more sense to do that? Like, because it means that it dereferences to that type, but at the same time, it's a reference type, right? So when you get a reference, you say like reference and then the expression. So like, I don't know. Yeah. Yeah, and the reference is a postfix operator. Reference is a prefix for now. I was actually thinking that the reference should be postfix too, because then reborrowing also like becomes less annoying, right? Unless I do the automatic reborrowing like Rust does, right? But we have like a reference and then we like dereference and then reference it again like this, you know, because then this becomes easier. Especially if it keeps being explicit. Do you not need to do the reborrowing in Odin? Probably not, right? Does Odin even have the mutable versus like non-mutable references? In Odin, there is general pattern of types on the left, usage on the right. Array of pointers, events. But the inner type of the array is not the usage of the array, though. Right? It's the inner type. And while you say inner, you want it to be inside, not on the right side. Why is it on the right side? It's the inner type. It should be inside of those square brackets. No? So like the thing that I was considering actually is instead of saying that the type is a reference to t, we could say like a ref t, like this. This would be more explicit, I guess. This is something that we can do. This also like matches this t being the inner type, because now you see that it's obviously inside of the reference, right? Accessing the inner type is what's meant by the usage. Yeah, but like, okay. I don't know. Well, I mean, doesn't it mean then that in order to specify the type of a field, right? So like, okay, let's try to follow that logic if Odin is using that logic. So if we have the struct type, right? Like whatever you define it as, like struct, right? So over here you have the field, and over here you specify the type t, right? But isn't this the other way? Because like you're supposed to like get the field. Well, I mean, yeah, you're getting the field of the struct, right? You're getting the field and you get the type. It's a little weird. You are supposed to like what's the syntax for this in Odin? Is it a colon there? Let's see here. Odin struct type. It's called record type, right? Yeah, you just say like name and type, right? But like since this is how you like this also like doesn't match it, right? Because in order to get the field, you need to say a dot, right? Obviously, so this doesn't match the usage versus like definition already. And then which is why I think that the dot syntax here is better, right? But then if you say like that there is a colon here, then doesn't it mean that when you define the type, which is like a reference, right? So you have like a reference, and you get an int, right? So which means that so like in this case you do dot field and you get t, and in this case you dereference and you get t. You know, like so like there's a colon missing then, right? Unless you do the no colon here and no colon here, then this is more uniform, right? Yeah, why is there no colon and no dot here in the struct in Odin? Anyway. If state. I was doing something like top level item definition span. If this or the map get name. This is some previous other span. Right? In this case, we say that it was already defined. Otherwise, we just say top level item definition span. Add name span. There you go. So we do something similar to this diagnostic here. In this place, where we say that top level item name has already been defined. Previous definition is here. And this is the other span. And this is my span. Right? Okay. Now that I'm thinking about it, I'm also not checking that the fields are all unique in the structs and the things. Okay, let's leave that for later though. Let's not make all of the error messages yet. Okay, and then I also don't have the dot syntax yet to access the field, right? So that would be the next thing to do. Right now I can just initialize the thing. Right, let's have this test. So we have this foo. How about we say that... Actually, what's the representation of the union? I feel like the union should just be represented as the value itself, right? When I compile to JavaScript, at least. We just have this name so that we know what is the variant. Yeah. Maybe actually it's like, shouldn't the definition for the union be like instead B like this? That would be a little shorter. But like, yeah, I don't know. I already did it like this. With a dot. Yeah, because otherwise how do I get the variant out of a union? Yeah. Can I make this like more uniform somehow? Like union is in between basically of the proper sum type and like the thing. So in regular cast, when I initialize the variant type, we just say like, you know, like variant, and this is the associated data like this, right? I can do the initialization like this for unions, right? But how do I get the correct thing is the question, right? Because right now we have like the union value dot variant basically, and this is how we get it. I mean, we could have like, you know, we could have a syntax like dot variant like this. Dot colon variant? I don't know. Let's keep the current syntax. That's okay. Debug print as foo. Debug print as is a function which takes which takes like s. Don't return anything, so this would be like native console log s. Identifier foo has already been declared. Oh, right. We support shadowing in the minicast, but not in actual, but not in JavaScript, right? Let's just call this not s, but not foo, but s here. That's okay. Right, there we go. So we have like the object, A is 1, B is 2. Okay. So the U is the union. Let's also debug print this. I feel like, yeah, I feel like for the union, I just need to transpile this a little bit differently. We need to debug print U. Okay, it just says B is null. So this is null over here. Yeah, like this is like unnecessary indirection basically, which only hurts the performance, technically. Right? I mean, in this case, we do see like the active variant of a union though, so maybe like this should be a compilation switch. Let's not do it yet. Let's not do it yet. Let's literally do this. Yeah, because then we actually see the active union thing. All right. So now we want to print s.b, right? And we want to print u.a. And this is not going to compile because... Oh, wait, it compiles? I already have the dots? I thought I did not have it yet. Okay, I have the dots apparently already implemented. When did I do that? Field. Yeah, I have the field already. Okay. So that just works. Do I have the field type? Yeah, so we have like field type function, which says that this doesn't have fields, right? And if it's a union, yeah. This is right. Okay. So we can initialize structs and I think okay. Let's do this. Let's test the error cases, right? So first of all, if I right now say another type, like U is type a unit, for example, then it's going to tell me that help level item U has already been defined. Over here is the first, over here is the next one, right? Okay. If I try to initialize the field A here multiple times, if I remove this, right, it's going to say that field A has already been initialized over here, and previously it was initialized over there. Okay, yeah, I think this is good. Okay. Mini cast records. Okay. What is next? Let's see what is the next feature that is needed. The angle and the way your cam is moving when you type makes you look like this StarCraft NPC portraits. Oh, do you actually see my fingers when I'm typing angrily on my keyboard? I can move the keyboard a little bit like closer like this. And then the head is too high up. There's an earthquake every line code you type. Cannot read properties of undefined reading vars. Oh wait, hold on. I have a miscompilation on the bootstrap where oh wait, or is this like this is the undefined? It's probably like the context that is not present. I'm trying to get the vars in somewhere. Let's see, do I have vars? Yeah, we do have vars, right? And this is in this scope, which means that the scope is not present. Right? Why would it not be present? Because I'm parsing expression and the expression is a constant, right? Yes. Wait, but where? What am I parsing? If only I had a stack trace here. That would be nice. When I like I cannot find the context. Maybe I should be able to catch any exception. Wait, is in JavaScript the type error an exception that you can catch? Can you catch type error in JavaScript? You probably can, right? Yes, you can catch it. Of course. Because type error is a runtime error, of course. Why would I not be able to do that? Um. Okay, let's just figure out why is the context not there. It's like I imagine because I say with scope context be equal only over here when I'm parsing a function, right? But we sometimes might want to parse. Yeah, so like it's basically means that I'm doing this outside of a function. Why would it happen outside of a function though? Let's take a look at the generated minicast code, maybe. Like, this is it over here. That makes sense. Because this is a generic, and generic is not a is not done being done as a function, but I still want these to be a function, actually. Yeah, that makes sense. Because like in Kast, we don't make the distinction between functions, values, and like types and whatever, but in minicast we do. So I need to actually transpile it as a function, right? So when I say minicast transpiler, right? When I have a value function. No? Yeah, like transpile value shape. Transpile function expression. Transpile value. Like this is the thing that is. Wait, do I even have any functions there? I'm wondering. Like I want to find a const. I want to find a const. This is equal. How do you do alphanumeric here? Word? Just like this works, right? Yeah. Wait, this doesn't work. Wait, do I not have the main function? I do have main. Wait, what? Why is this not found? Right? That it basically means that main is the only function. And that's what it looks like. Okay. Yeah, so like those should not be constants. So how do we do this? I say that when I transpile value and if this one has an right, so like const with transpile type, and we do the value, right? Yeah, mini AST const and type is type. I mean, shouldn't I just say that if this? How am I doing main? We add the function context functions. Yeah, we literally main is the only function. Okay. Yeah, like so we need a dedicated thing here. Right? And this should actually be unreachable then. We should never compile functions as values, as constants. Okay, so instead I'm going to check at over here, right? So if this is a shape, over here I'm going to match shape with, so like by default we're going to do that, but if it's a function, or a generic, then I need to transpile function expression. This gives me the expression. Oh, I need a function definition. Oh my god. Transpile function expression. Oh, it has like the function. Yeah, hold on. We just get rid of this. This should return not the expression. It should return the function definition, right? Transpile. We just call it transpile function. Right? And over here, when I transpile this thing, so when we do the expression, this is when we transpile this thing, and we have the function like that. And over here we say function like that. There we go. But over here we have the function, right? And I should say context functions. It's context functions. This is the same, right? To memorize generics. Yeah, we just say that context functions, string map add value name. I guess we can still do the same name here. And this. And this is the value expression. And then we claim identifier value name. So we don't say this. No, we do say that. Fine, let's say sum here. Oh my god. Close this. Over here, we return none, and over here we return sum. Right? And then we say that match value expression with none, and we do nothing. If it is some value expression, then we do this thing. Okay. Transpile function definition. There we go. I think this should be better. It's the same stuff. Cannot read properties of undefined. Okay. Does it mean that this did not help? Let me see. Compiled. Right? Because now I should be able to see the functions, right? Yeah, like this over here is just a function now. This is just a function. This over here is create a new empty list. Right. So what are we looking for at current? There's only one current context, which is over here. But I'm looking for the vars specifically. So this is when I'm looking up the symbols. Oh, wait, no. Yeah, I still need to look up the symbols when I'm initializing the constants. That's right. Because constants can depend on other constants, right? Which means that when I'm processing the constants, we should technically like have no scope there. Right? Yeah. Okay, so I think we technically just maybe whenever I compile over here, I always have the scope, which is like an empty scope. empty scope for initializing constants, right? Is needed for initializing constants. They do name lookups, right? I mean, or either that or we need like the context system to be like optional. Which I'm not sure if I want. Yeah, and parent scope is none. All right, what is the next thing? Is the mini cast compiler even like slower than the cast compiler? Const is not found in the current scope. Over here, right? So okay, so this over here is initializing this constant before this constant. I think that we might actually have circular dependencies here. Do we have circular dependencies? This over here is the prelude. Right. Yeah, this over here is the prelude, and we can see that this thing is actually being used over here to initialize this over here is the standard library. Standard library has the prelude, but the prelude depends on like these other values, right? Yeah. Yeah, and we cannot do that. Wait, what was I doing in the JavaScript? I was actually doing some like late initialization, I remember. Late. JavaScript, not minicast. Late. Yeah, we have like this prepend late. So when I transpile a place, I prepend late. Let var be that. Oh. Wait, what? Where the place we transpile value, this value is what? No effect expression, and we prepend late, like the actual value is being done there. The value of this place. Prepend late, let value name be equal to this. Can be deleted is false. I think this is what I was doing. So like, Yeah, I think we should be okay with the circular dependencies in the form of the functions, but not in the form of the values or something, right? And this was like a hack, I think, maybe the way I was doing it, right? So like, why is it initialized earlier there? Because the prelude depends on, right? So this is the prelude, and prelude depends on, let's say, on the option, right? So option should be defined earlier than the prelude. But that is not the case. Wait, hold on. No, I don't get it. Actually, hold on. Prelude is this. I should maybe try to compile something simpler with like no standard library. Do you have the NoSTD here? Minicast, path, args. Yeah, can I have like the no STD, which is optional argument? Let's take a look at this just file because I did do something, right? Yeah, let's do that. Let's have the no STD here, which is going to be the no STD, which is by default the empty, but otherwise it's going to be no STD. And then over here we say cast compile no STD, right? Can we use a dashes in this? I'm not sure, actually. And we have no STD like before the path. Let's see, just the minicast, no STD. Non-default parameter path follows default parameter. It needs to be like over there. Is that what you're saying? So we need to say just minicast no STD, right? So, but if I say no STD, then print is not in scope, obviously, right? But maybe we can do something with like this over here, right? So we want to say that STD is a module, right, which says that like print is as string is a string, right? And then this turns unit, and this is going to like native console log s, right? And over here we say std print hello world. I'm gonna do playground test. Okay. I'm going to go take a lunch break in a second. Let me just do this. Yeah. Wait, so this actually has the same error. Okay, so this is what we're going to figure out then. Right. Yeah, I'm going to figure out why does this not work. Maybe I do it in like the opposite order or something. I don't know. All right, I'll be back in like 10-15 minutes. All right, let's see what's wrong with this code. This code is really small. Right, so we define first couple types. This is the type of the standard library, which has this string, which is a type. Types are just empty structs. And I have print, which is this type, which is this, which is a function taking a string and returning unit. And then we create this constant. And then we create this constant. And then the error was what? That the this constant is not found in this. Yeah, for some reason this is initialized after this one. Why is this? Oh, because this is a type. Hold on a second. It's because this is a type, right? Oh wait, I know why. Because this is not how it's supposed to be, right? I'm printing these things in the sorted order instead of the order of the like we are doing the topological sorting of the things, but then I get rid of that because I just I use a string map. So we need instead to do in the transpiler to minicast, we need to maintain the order of the constants. So the order of the functions doesn't matter, the order of the types doesn't matter, because we want to support recursive types, recursive functions, right? But the constants recursive, we don't want that, I think, right? So we say const over here, string map add value this, right? So we're going to say context const order. Well, do I use the consts in general? Yeah, I feel like it just should not be a string map. It should be a list, which is an empty list here. And this should be a mini ASD const, which so const should have type, value, and name, right? And it should not be a string map, but a list of constants instead. So let's do the generate here. So over here we say generate add last context const, and this is the const, right? Where name is value name. So this is going to be generate create, and over here these constants should also be const list, const generate to list. So we say we iterate over the const like this, and we write const name here. There we go. And const type is never going to be a function, so we actually don't use const for functions. There is no kek here. Literally just do this, right? Don't do this anymore. So it's not string map, it's just list. All right, let's try this again. Expect the function got the type. Okay, so this constant dot print is not a function apparently, according to this. But why is that? It's because It says that we got type 192913, which is this type, but this type is a function, right? Right. So we don't resolve the type aliases apparently somewhere. Wait, isn't this supposed to be in the type checking? Right? Yeah, I resolve the type alias of expected and actual. Expected the function got this type, right? Oh, wait, expected the function is different. It's not the type checking, right? Expected over here. Expected a function. There we go. Because this needs to be resolved. We don't match F type, we match resolve type aliases of the F type. Right. Recompile. What happens if I... Doesn't matter, okay. It's recompiled. Let's try again. Cannot file or directory JavaScript runtime. Okay. I think I just need to fix my just file here, right? So we do know, yeah, we should say like JS runtime is this. I want this to be the real path, I guess, because I am changing my directory here. Yes. Okay, it's going to work now. It didn't work. Oh, real path says no such file or directory. Oh, because this is okay. Runtime JS. Let's do that. Runtime JS. Runtime JS is this. Before I change the directory, right? We have unexpected token as semicolon. Wait, what? So I actually compiled this to the JavaScript, but then it doesn't work because wait, I think I made a bug in my file actually. Test over here, right? Because console log, this bracket is actually not closed. Yes. So it's not a miscompilation, it's the incorrect code. Okay, now we have this. Cannot access the constant before initialization over here. Let's take a look at this. I think this is probably the same. This is probably the same where this is probably the same issue where I sort them by name when printing the constants, right? And I should not do that. So and this is in the minicast now. Right? Because in the minicast we have the constants like this, and this is the ordered map, but we want to maintain the order of constants. So it's like an ordered map with like while maintaining the order, or we can have like a separate const order is going to be a list of strings. We can do that too, right? Yeah. So when I print, I just don't go over the constants. This is useless. Now it's in the JavaScript, right? When I go over dot consts over here, I don't do order map into iter, right? We need to do something else. We say for name in a program consts order So this array list into iter, right? So this over here we say that value is ord map remove from the program consts name optional wrap, and then we'll let var name calculate value, right? Like this. Which means that program needs to be mutable here. It's okay. I mean, I could also like get, but then like, yeah, that's okay. Which means that in order to construct this over here in the compiler, we're going to say that program consts order is a new list, and when we say well, I mean, I do have the constants in the form of the of this. Oh, but this is like the AST, right? Yeah, that's different. Okay. Consts. Yeah, which I would say process consts. That's what I should go into. Right, so this is like value is this, and then we just add it over here, right? But what I should do instead is I should also context program consts order push back name, right? Okay. I mean, I think ideally we like want a combined map type which maintains the order of insertion, so we can iterate over the order, but it's okay. Is that like often needed? A map where the order of insertion is important? Like a linked ORD map or a linked hash map. Well, I mean, technically, we don't want this to be ORD anyway. I just don't have hash maps yet, right? Okay, there we go. We go. Hello world. This is still not the correct STD, but this is something. Okay, and now if we go and we do minicast the actual hello world, we're going to see the next thing that is not compiling, probably. We have once again the constant that is not found in the scope actually. That is the same error. Right? So this is the neg. So this is the standard operator negation, and this thing is defined. Wait, this thing is not defined anywhere. Wait, what? How am I using a constant that is not even defined anywhere? That's wrong. Unless I'm adding to the constants in other places. Nope. I'm not doing that. That's not in the minicast. This is probably, yeah, I mean, this is the minicast that we generate, right? So the problem is the cast to minicast. Okay, so for some reason I don't. Oh wait, because this is a function. Because this is a function. That's right. Because neg is a function. But am I not adding it as a function? And I thought it would be added with the same name. It's when I transpile a value over here, we see that if this is a function, Then I say that we have a function by the value name, which is this transpiled function, right? Um, let's go again without the no std. It's because it's a generic, maybe. So let's try the dbg print, right? We can have dbg, which is another module, inner module, which has another print, right? And this is going to be a generic t where we have x of type t. This returns nothing, right? So, and this would be also, I mean, technically this is also just console log, I guess. X, it just doesn't have to be a string. So what I want is std print 1 2 3 4 5, which is an integer, and to define an integer then like this, right? This pattern match is not exhaustive on the self-hosted mini compiler over here, right? Because this says that when I resolve the type aliases, yeah. Okay, yes, because we have like more types now. Resolve type alias, right? Because we have the int 64 char. We have float. We have the any type. Which by the way means that it actually is not going to work, because this is a generic which is going to be transpiled using the any type, right? And that is not going to type check. So we need to the type checker to ignore the type checking of the any's. Right? Wait, no, it says expected expression got 1 2 3 4 5. Okay. In this case, the 1 2 3 4 5 over here, this I just need to make the literals. Let's just say for now like this, so that I don't have to do it. So yeah, now I expected this type, but I got unit. Wait, what? Wait, what? So this is, yeah, this over here is the generic, right? Which returns this type. And this is the type which takes any and returns this. And this is the unit. Type 6.5. Yeah, this is the expected type. But we got a unit? How did I get a unit here? What? This returns the lambda, right? So, that's definitely not a unit. Oh, is it because this is a then? Because I have the error message over here, not just for the function, but for this. Let's let's see. So when I compile the then over here, right? Yeah, we have then. Last expression type is unit, right? Yeah. There we go. It's because I update the last expression type. Yeah, we have this expression, and I just need to update last expression type here is equal to expression type. There we go. Hmm. All right, now we have a different error over here. So now we're trying to debug print the const, right? Now this const has the type. No, yeah, we have the type this one, which because this is the constant, right? That I'm giving it. And but we have the type 57, and type 57 is just this wait, what? Hold on a second. We do dbg print. I'm debug printing a constant. Oh, right, because this constant is a type. That's right. This constant is a type. So this should be a type. Wait, what? Wait. This is different. This is wrong. Hold on. What did I do just earlier today, right? I have replaced. Oh, no. Yes, this is. Wait a second. Wait a second. No. What am I doing? Like this. This is the one, right? So we're transpiling the dbg print. I should probably like make the better names here. It's like const number and a type number. I actually have the names of these things, right? So that it's easier to debug. But this over here is the dbg print, which is a generic function which takes the argument, which is the type, which is the type t, right? So this over here is the type of a type, which is just an empty struct here for now. And then we return the type, which is like the function. So now, because we don't do dependent types, the type parameter becomes just any. So this is correct. Right? But what we don't like is that, so dbg print is this thing, and it takes the argument, which expected to be 57, which is which this, right? So this is a type of a type, right? But we got the 9.4, which is this, which has dot zero. Oh wait, no, I understand why. Because yeah, I should fix it. It's because we treat the functions, all of the functions, as the functions that take a single argument. So this is the single argument over here. The underscore 0 is the argument which is of type. So I'm calling it like correctly, but in the definition, I'm converting the type as like it still is a single argument. Right? Wait, I thought I was fixing that already. Oh, wait, it's the right, like where is this type used? Only in the constant. Yeah. It is only used in the constant, but this constant just has the zero, so like this is like the actual argument that I have. So this is the Kast to mini Kast compiler, specifically about the generics. Specifically when we instantiate generic. Yeah, over here we say argxis tuple is false, but I actually want the argxis tuple to be true. The only issue is that, well, I mean, it should be true, right? Well, let's see what's going to happen. Is going to say that exception, a function args must be a tuple, but it is actually not a tuple, but it's a constant of a type tuple. That's the thing. Right. So can I call a function and the argument is expression, right? So this expression can be a constant, which is a tuple, because that's what we do. We are inferring this thing. Yes. Okay, so yeah, I just need to like see if this is a constant. If it's a constant, we have the value, and the value in this case must be a tuple, right? Value tuple is value expect tuple. Option unwrap or else. Fail f args must be tuple. Okay, so now we have the value tuple, and we're going to do something very similar here. But now it's not the parts, I guess. Now it's the value tuple, tuple, this value, expect tuple, value tuple iterate, function member value, member field. So this is the value tuple field, right? You've watched an entire film in the theater and you're still live. What's the film that you was watching? It's been a while since I was last. The new one with Ryan Gosling. Project Hail Mary. Did you like it? Well, I mean, the movies usually they just go for like 2 hours, like 3 hours at most, right? And the streams are usually longer, so it's not like that weird that I'm still live, right? All right, so we like create an argument for all of this. We transpile value here, which is field dot place interpreter read place. The field access value tuple has type tuple field tuple, but first always state of type list. Right, this is called tuple iter. Okay. All right, so let name is match member with index non name. Wait, what? What is the args? It's an expression list, right? Yeah, like this tuple, we are doing that, right? So yeah, we're calculating the arguments first and doing this. Casting takes more effort than filmmaking. I don't know. I've only been doing it for a little over a year, right? We like movies are being made longer usually. I'm not sure though. Read place and then like transpile value, right? Yeah, like this. So we'll let var be that, and then we do that. Yeah. Wait, is transpile value not always just returning claiming the identifier? Right now it does. Okay, let's not think about it too much. Like, we are generating not very, like, good code, but it's okay. Okay, so over here we have type name, and I'm printing the type name in the minicast. Type name, right? I want to print it here. Okay. Let's see, we have unit, boolean, int 32, int 64. We have the float 64. We want to have the any type. There's also a char. Okay, so I think like right now it was trying to print the error message where like we expected any type. Yeah, expected type unmatched value. No, this is different. This is, I was trying to print any, right? But the reason I was trying to print it is because we have a compilation error. Yeah, expected type, and there you go. After I printed the expected type, we have this, right? So we expected any basically, but we got not any. And that is the issue right now. So if I do this again, yeah, expected any, but got this type, right? So because this argument over here is having like this type, which is the integer, because I'm debug printing an integer, right? I just need to fix the type checking here. which says that if this is any, then like we don't check actually, right? Which means that structurally equal is not something that we should be doing, but we should instead recursively go over the types, right? Yeah. We should recurse over the type. Const type check. Type check impl, right? It's going to be like, expected type actual type. So basically what I want is I want to type check impl the expected and actual. And then this is the diagnostic, which is going to be yeah, let's see here. We're going to basically over here, we're going to match expected and actual, right? And over here we have all of the things. And if not, then we're going to throw the thing, which we're going to catch over here. So we're going to have like two error messages. We are going to say that expected one type got one type, and then we're going to like where exactly they did not match, right? Some of the inner type, maybe, is what I want. So for that, we will have like type check context to be a thing where we want to fail, which is a function taking a message, and the message is just a function like this, and then we return t. Okay. Right? Yeah, so we're going to match. I'm going to need to go through all of the types. This is all the types that we have. And I need to like resolve the type aliases first. Here. Dun, 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 dun. And we're going to say with type check context being this, where if we fail, which is going to be like the message. I mean, maybe it should not be like the message, but it should be like two types that we have here. Expected type, actual type. Yeah, why not that? So we have fail is expected and actual, and this is where we do the diagnostic reporting. But I'm going to, yeah. Hold on, let's say like this is going to be inner expected, and this is like the inner actual, right? This is generic because it simply returns the never type, but we don't do the never type yet. In case anyone was wondering. So we have the error, we say expect type expected, got type actual, and then we have the related information. I mean, what is the span of the related information though? Is the question. Like the span is the same then, right? Like this is it's still part of the same error message then? Right, we just say output, right? /n. And then we say like another expected type. Right, like how should this error message look, right? So for example, we say something like this: expected function string into unit, but we got a function int into unit, where like why are they not equal? Because string is not because string is not an integer, right? So maybe that's what I say, right? Because expected this, so this is the inner expected and this is the inner actual, right? That's what I want. So now we have this. Let's see. So these things, they should be like that, right? So here's what we do. If one of them is any, then we don't do anything. If so, the first one is any, or if the second one is any, then we don't do anything, right? If the first one is reference, and the second one is reference, then we should just type check impl AB, right? If we have a list, AB, then we have type check impl AB. If we have a unit, then it's okay. If we have an integer, that's okay. Float is okay. Char, bool. If we have a so like if in the other cases we're going to say that current type check context we're going to fail with expected and actual, right? So if we have a named A and named B, list is a built-in type. Yeah, in the minicast it is. Well, I mean, it is the built-in type in the regular cast too. I feel like it has to be the built-in one. Maybe, I don't know. We'll see. I might like change things in the future. I think we also might have a map as a built-in type, but I'm not sure about that. I mean,
Hello,
yeah, like I have the contexts in the minicast. So if I wanted to implement the contexts using like the other functionality, then would need to have a map as a built-in type. Hello, just Fanta. In the fixed size array as a built-in type, yeah, probably. But for now, I don't like really need it. You don't really need it. You want it for the maximum performance and stuff, but technically you don't need it because we can compile to C and have it in the C runtime. You know, the arrays. But yeah, I think that we will want the fixed size array, sure. So maybe we will switch from one to the other. But I mean, at the same time, the lists, like, maybe like I should have both. I don't know. Also, like the list should be renamed, right? It's the dynamic array is what we mean here, right? I still call it the array list in Kast. In the type system, I call it list, though. I don't know. Okay, named A and named B. I say that if A is not equal to B, then we're going to fail. Right? Is it an active anti-C++ decision to not name any of these VECs? Yes. I don't like VEC because I like working with math, geometry when making games, and the 2D VECs are a conflicting name then, because like maybe if 2D VEC means that you have like a two-dimensional array, which is dynamic, then if you name the regular dynamic array the VEC, right? So I call it array list right now, which is okay, I suppose. But the dynamic array is another option. Even the initial designer of the std vector API later disagreed with the naming choice. Did they propose a better name though? And also, like, was this after the Rust copied the vec name or before? Or are the Rust developers not familiar with that opinion that it's a bad naming choice? Actually, you know what? Hold on. This is not expected an actual. I think this actually should have a message. I think that this should actually have a message. Right? Because I will want to say for the functions that, like, argument, like the amount of arguments is different or something. So it's not just like, oh, this is not equal to that. We just fail, and this is like the message that I want. So over here, we just say, so like this is the inner message, right? Which I just call here. Right, so in this case, we just actually say that we expected. Let's see, what do we say here? How about this? Short type name. How about this? We have the type, and this gives me the string, right? So I will say something like expected short type name of expected, right? Otherwise a short type name of the actual gut, right? So for example, okay, let's match type here. Right, we don't care about this inner types, right? But for this we say any. For this we say we say expect a reference. This expected a list. Cinematic camera angle. Yeah, exactly. Cinematic. That was the thing for sure. That was the goal, to make it cinematic. So when we say function, for example, we just say that we expected a function, right? Or in this case, we say a reference, a list, and yeah. And name, this should just be the name. Maybe in this case, I could get like the actual definition. How about this? Context. Is current context program types get name definition is this, and I would say, you know, like I mean, yeah, we just like match the definition. So over here we say an enum I mean enum, maybe this opaque union struct alias, although this is supposed to not be here anyway. Short definition is this. Yeah, so I will like print something like name plus opening bracket plus short definition closing bracket, like that with a space, right? This is the short type name. Well, I mean, if it's an alias, I should like do this, but this is done already after the aliasing has. Yeah, whatever. It's okay. If I say a list though, if this doesn't type check, I feel like we can do like the overriding with the extra information, right? We just say type check impl, and then we say like with type check context is, so we say like fail is the message where we like, wait, basically we like do this message, but we also add another message first, right? Where we say and output right, list element types are different. Nice error messages. Yeah, I think like we can make the minicast pretty nice in terms of like error messages and everything. I'm considering doing the LSP for the minicast too here. Right? Because it should not be that difficult. Anyway. Okay. Yeah, and over here we say like something similar, where we say referenced referenced types are different, right? And over here we just fail. What do you call a baby cast? Castling? Castlet? Should we rename the minicast to castling? Is that what you propose? I don't know. I just call it minicast, but I did not think of making like a better name for it. Do you think we should name it something better? But I want the minicast to be like basically a sub command of cast, I believe, right? So we say the cast mini here. Right. And if we later do the microcast, it would also like be like that. I don't know. Minicast makes sense. Not sure if we need a different name there. I think in this case I don't do anything. Well, no, I do say that. No, let's actually say this here. Let's say here output is current output. Output write A, write not equal, write B. Does Kast have a mascot like Ferris or Rust? Yeah, you can see it over here. We have the unicorn, the spherical unicorn. Does the unicorn have a name? So you want to call this unicorn a castling? No, it does not have a name currently. We love stupid questions. The name is important, of course, but I don't know. I just didn't think about it. But it should be definitely like I don't like the fact that the Rust mascot is called Ferris, right? Because the name is not really connected with the Rust. Like for the Go, they have the mascot which is the gopher. So like you say gopher, you understand it's for Go, right? So we can call it castling. Yeah, I understand it's because ferrum is iron, right? But iron is not rust necessarily, right? Okay, we need to type check the functions. So we say that if, so we have function A and we have function B. These are function types. And function types have arguments and result. So we say if A args, if A args length is not equal to B args length, then we're going to fail. Expected this many arguments, but got this much. Zig's mask is called 0. The whole Rust kind of wordplay thing with great names. Yeah, why did they choose it a crate? Because it's a cargo. But why did they choose the name for the package management to be cargo? Is Rust usually shipped in crates? Like, can you order a crate of Rust for yourself? Or something? I'm not sure. Okay, we expected these arguments, got this, right? And then we are going to say that for I in 0 to ARX array list length 2. Okay, so now we need to type check concrete arguments, right? And we say that we're going to type check. We're going to type check a args at I. By the way, shouldn't these be references here technically? I feel like it should be. You know what I just realized? What if you do this in Rust? Isn't this supposed to not work? Hold on a second. Play Rust lang.org. Like, we don't have like the borrow checker and anything currently, right? But I'm wondering, what if we have, you know, enum A with like A, B, right? And enum B. Well, let's just have one variant for simplicity, right? Enum B is also, well, I mean, just enum A, that's all, right? So we then say that let A is A, right? Let B is AA, and I want to match AB with yeah, and let's try this, right? Let's say type check A and B, right? I want specifically the references because we don't want to take ownership of this. Type check A B A, right? So what I want is I want to type check A and B. I mean, wait, can I like go to the previous Rust, which did not have the match ergonomics? Like, that's what I'm talking about specifically here. So if I say AA and AA, then we like don't do anything, right? Like, doesn't this move this thing? Oh, we need to do a colon. I forgot how to write Rust at this point. Yeah, we cannot move out of A, right? So how do you pattern match in the old Rust where you were? So like right now you can do this, right? But in the old Rust you could not do that because, oh wait, no, you can, but like then you have to do like a reference here. Yeah, no, never mind. Just a little bit annoying that you have to do like references in all the places, right? So the match ergonomics is what like lets you not do this anymore. But I don't have much ergonomics in Kast yet, which means that this is what we have to do to satisfy the borrow checker, which is the imaginary borrow checker. Now you can read in Rust, but not write. Bum, 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 bum. Yeah, so like we still do this. So this is a reference to any, right? And this is a reference to any. Do we even support the references to the things? Let me see. Cast std syntax is what we want, right? We have a reference is over here, but the variant is over there. Yeah, I cannot do a reference to a variant without like, because this also now requires parentheses actually, and this is like very annoying. I think implementing match ergonomics is like not that obvious. So I can like ignore the fact that we are not doing the borrow checking properly, though, and just do this for now, but it will break. Unicorn giving you Constantine vibes. I don't know. What are the like common unicorn names, guys? Can you guys name a single unicorn that you know? I don't think I know any unicorns. Maybe we just rename the language. I don't know about that. I think the language is already nicely named. What do you want to rename it into? The last unicorn. The Python thing is called Unicorn, is it? I thought the Python is just Python. The snake. Do you say argument number 0 or number 1? When you have the error messages given to you in the for the humans, should it be 0 based or 1 based? The only named unicorns are from My Little Pony or something. Are they unicorns there? I thought they were ponies. I never watched it, but I thought they were ponies, not unicorns. All right. So we are trying to type check the arguments here. A, B, right? And then I also want to type check the result type. Right. Result type is different. Type check A result, B result. Okay, so I think maybe this is all that we need to do if this compiles. Data not data mismatch, WF enum over here, right? Because enum underscore. T is not unit. Oh, right, because I want to like override this thing. Parent context is current type check context, right? So over here we parent context fail with this. And the unicorn after the daughter. Well, Kast did start basically being worked on, I think, basically at the same time as my daughter was born. So yeah. But I don't think so. And she's also barely speaking, just like the cast itself, right? What is this? Reference type is not type. Where? What's the issue here? Because type check impl. Expected a type. Yep. List A, list B. Oh, because list ref A and list ref B. That's right. I feel like in terms of the error messages, the minicast is going to be a lot better than cast. Yeah. For sure. Okay, there we go. Hello world. We have hello world and we have debug print. And this works. And I have the actual hello world, then could not find print in scope. Yeah, because this one, yeah, we want with standard library. Okay. So what's the issue now? This is the same issue as before. We have the negation, which is a constant, which is not even present here, right? So why is that? I don't get this. The transpeller to minicast is just like not doing some things. Let's see. Well, like, why would that be the case? Right? Because I'm literally just transpiling the value, right? I'm transpiling the value, and I'm saying that we add last const, or we return none here, but in this case we have the function, right? Because this is obviously a function with the value name. Am I not printing functions maybe or something? No, yeah, functions is constant function. Like if I have the main function, that it means that I should be able to have like all of those other functions too, right? And if I have the minicast AST dot functions, yeah, I'm definitely going over the functions. I don't get how this can even happen. Am I overriding the context? Hold on. With effect. No, I'm not. Like, this context is only being handled over here. So this is the only context that we have, the global one. So that makes no sense. Try to transpile this. Value name. How to get the name, and then if, like, I guess do prepend is false, even although name is somehow. But why would that be the case? Yeah, we'll generate name const only like this, only in this place, right? And this would mean that do prepend is true, which means that I should add this here. So yeah, but I'm adding the constant only if it is, if we have the value expression, and we don't do the value expression only for functions or generics, which is what these things are. Wait a second. I think I know. You know what happens here? What happens here is the order of evaluation in OCaml. Well, I mean, even if it was not OCaml, I guess this is wrong. It's because, like, OCaml doesn't have the mutation. So, like, what we say over here is that functions is functions, and then we add to the functions this thing, right? So what happens here? We first calculate the functions. So this is the current functions, right? And then we're trying to calculate the value that I'm adding into the functions. And while I'm calculating this, the functions are going to be mutated. And because of that, we skip some functions. You know what I mean? Because this is not mutating. This is assigning some old value being changed into the new value, and then we like reassign the thing. This is why mutation is strictly better than the functional style. Right? Like, obviously you can be careful here, but if we had mutation, this would not even have happened. So I need to like calculate this first and then add it to the map, because then we like get this. Yeah, let me look at all of the mutations actually. Right, like over here, this also can happen in the contexts. And this, I mean, this over here is okay. Yeah, because we update. And we don't calculate anything here. Okay, maybe this is okay now. All right. Well, I mean, yeah. I mean, technically I'm using mutation here, so it's not like really the functional style, but like If I was writing Haskell, then that would be what, like get and set. So like basically get and set, like through the state monad, for example, is bad because you want instead to update directly your state. Yeah. Expected expression got 1. Okay, so we don't support the literals. Let's support the literals. Fix mutation bug. I'm wondering if I have the same bug like in JavaScript. Transpiler, potentially. And we just have not seen it for some reason. Okay, we want the literals, which means that I want to have an expression shape, which is just the, so we have the string literal, right? I also want to have the char literal char. I want to have the we'll just have the number literal, which is going to depend on the type. I think that's, I mean, actually no, let's say like int 32 literal. What if we just say literal, right? How about this? Literal is an int, a char, a string, right? A boolean. Boolean int char int 64 and so we have literal, and we're going to match literal. We just do toString and the output. Oh wait, no, this is JavaScript. JavaScript does not have the, that's not this. The JavaScript still has the string literal, right? As a dedicated thing. I mean, we could have like other literals, I guess, or whatever. I mean, in JavaScript I can just do raw. Eh. Yeah. So here we don't do this string literal, we say literal string, right? And if this token is the number If this is the number raw. Wait, what do we have in the tokens actually? Token. We have the number. We just has the raw. Okay. So what we do here is I need the expected type, right? Expect known type, right? Expected type is expect known type. Expected type. Token span. You have geolocated me based off the clouds. Good job. Good job. Don't tell anyone. So this is literal, and this is like the literal, which and the type is just so this is just a type. My coordinates are 0, 0, 0. That's correct. I'm in the center of the world. This is where Kast development is happening. Edge type width. I want to resolve type aliases, of course, first. But if this is an int 32, literal. So we say like number literal cannot be print type name type. Okay, so if it's an int 32, then we say int 32 parse raw. If we have and this parsing can fail also, right? But we can no, we cannot actually currently. Yeah, like the parsing doesn't even panic. It's like doing the custom thing right now, so we cannot catch it. Let's ignore that fact. To do catch errors, catch parse errors. Okay, and in the JavaScript backend, we say if it's literal, then we're going to match literal. string s, then it's going to be string int 32, int 64, float. All of these are just going to be the number literal to string x. There we go. Right? Vertical bars. So we have string literal and we have the number literal, which, I mean, should the number literal just be like a float always here? This is JavaScript, right? I think this should always be a float 64 here. So it's not just string, right? It's a parse to string. Of course, that's how you do conversion. Right? Okay. Literal is not int32 string or float, right? Because this is float 64. And there's also a char there, by the way. If there is a char C, this should still be a string literal, by the way. That's how we represent the characters, right? Up to string C. Right. And I don't do the chars yet, also, by the way, in this thing over here, because if this is if this over here is a string, literal, right? This is a type. How about this? Let type and literal to be string and this. But that's not always like this. Hello, penguin operator. So the type and literal, like because like in the cast AST, the strings are also strings for chars, right? We have instead the delimiter here in the token. Token string has this is the string token, which has the. I don't even have the delimiter here actually. I mean, I can check the open token and check what it is, I guess, right? Sure. Can I like say that? Okay, let's like open raw is. Do we have tokens here? Let's have tokens. Right, so there's going to be a token, a raw, string, open. Right, so over here I say that if open raw is equal to a double quote, then it's going to be this, right? But otherwise it's going to be, well, if open raw is equal to this singular quote, I guess, then it's going to be char, and a char string add stir content 0 else panic unknown string delimiter if char string encoding length of C is not equal to string length of the stir contents, then char literal must have exactly one character. Well, this is going to like that not work if the length is 0, right? Let's say if it is 0, then cannot be empty. Okay. Let's do this. And I ran out of RAM. Okay. Let's take a look at our RAM. I was using 20 gigs. I mean, technically I have 10 more gigs of RAM. Right? Technically. Do you guys use swap? I, for some reason, have not been using swap like at all. Oh, this is like a string actually, not a char. Right. Because we will probably have like the multi-line string with multiple characters and the open thing. Only on your developing computers. Is there a reason for it? Or is it just because that's like what the default like Linux distributions set? They automatically make the swap. And how much swap do you have? I could have like a bunch of swap. I have 4 terabyte disk. STD, STR over here, yeah. I just remember, I think like back in the days when I was using not the SSDs, but the HDDs, like whenever you actually went into using swap, like the whole PC just started lagging. But at the same time, like right now it's not much better because right now when I run out of RAM, like also my entire PC just starts lagging and like I just have to reboot it basically, right? But if it's a swap, I would at least like not really have to reboot it. And also like it's faster than the hard disks because it's the SSD. So yeah, if I'm not careful, that I have crashed my stream multiple times with Kast already. It doesn't burn out SSD faster. Yeah. I mean, the fact that I'm using Nix instead of like the classic things is also burning my disk a lot faster, I guess. Pattern match non-exhaustive in the over here. Resolve type alias. Wait, what? Wait, what? Because we have the we have the reference, right? Resolve type aliases, right? We have the references. I also don't see the list here, right? So if it is a reference, referenced, then it should be a ref to resolve type aliases referenced. And if it is a list, of the element, that should be list resolve type alias element. No context activating Linux burns is faster too, for sure. Wait, why is the result type is different? It's spelled twice here. Okay, so we have a compilation error over here because into iter is a function, right? So yeah, like in this type somewhere we have something specified. Let's see, we expected this thing, which is a struct.iter. That's right. That's the iterable. Oh, because like it's a function and within a function. Yes, yes, yes. We have a function within a function. Wait, what? Do we? Oh, we don't. Hold on. Because I'm not supposed to go over the name types after we have resolved the aliases. Right? So this is the supposed to be the into iter. Into iter has this type, which is this type. Which is an empty type, which is a type. That's right. Because it's a generic. Okay. Let's try to make like the better names here because that is annoying. This is annoying a little bit. I think I actually have. Do I not have in the JavaScript like value name? Do I not have like something like value name? Yeah, we have value name. There we go, which is an optional name, right? Yeah, we have the names for generics. I could have the name for functions, but I don't do that yet, apparently. And then we have the names for like the for the types, type name, and type name is like this shape name, optional name, right? Which we only have for variant and tuple types. Yep. let's go into the minicast, and whenever I generate the name, right? Like over here, I'm generating the name type, right? But type might have a name, right? So can I say like type name of the type, right? Generate name from Kast, generate name. Type name type, right? Something like this. I want to say that generate name has the opt, which is optional name. There we go. So over here, when we say like the const, we will say that opt is value name value. This should be optional, right? Yeah. So basically, we say that let name be match optional name option and then fun name optional name await in third, right? So if we have none, then we just say name. What? There we go. This is what we want, right? So we have some name. What do we do here? So this over here is the name shape, which is simple concat instantiation. I kind of like want to, what do I want to do here? What do I want to do here? Maybe I just want to print it, you know, make string a name. Like, how do I print it? Print name shape name, right? That's what I want. But I want to like replace all of the weird symbols because like, yeah. How about this? Let name is make correct identifier name, right? And then we also have the ID there, you know? So make correct identifier name string. What do we do here? So I just need to like replace anything that is not like, yeah, let's do this. Result is there like a string builder in OCaml? Probably not, right? It's okay. Let's just start with an empty string and then like say name string iterate. We want to iterate UTF-8. Right? Function C and return result. char to int basically is the code. Like I want to say something like if we have char as alphanumeric. I mean, we can say the regular iteration, I guess. We don't want the UTF-8 characters here, actually, to be supported, probably. We just say if char is alphanumeric. Okay, let's see. If result is empty string, then let's say if result is empty string and char is digit C, then I say that result is equal to underscore. So we always start with underscore, at least if it's like this, right? But otherwise we say that if it is alphanumeric, then we say result is result plus, can I add a string? Result char string make 1c. No, we don't do end in a camel. Right. Yeah, so like otherwise we need to say result. I mean, we can just like skip the incorrect characters, right? So we just support the alphanumerics. Or C is equal to underscore. I think those are the only thing. Alphanumerics and underscore, and we always start with an underscore if it is a digit. Yeah, I think this is good. Let's see what's going to happen here. Wait, this one is not inferred and it's going to be awaited? Oh no, because I'm trying to get the name of it. Yeah, there is something that is not inferred here. I know that there was something that is not inferred here, but I'm not exactly sure what is it. What exactly is not inferred in this thing, in this place? Is the generic argument that's not inferred? Is that right? Yes, actually, wait, this is actually right. This is not inferred, and this is not inferred. Why? Well, now what I want to return. Let's just say T here. Like this actually fixes it. Let's ignore this issue and make sure that it's inferred. And then over here, we also say iter T. I don't know why the inference does not do this. So now we actually have everything inferred, which is good. Now let's see the actual error. Right, so there we go. We have lib iterable type T. There we go. I mean, this is better than the previous name, I suppose. Yeah. Maybe like we could like replace the other things with underscores. Yeah, you know what? How about we say like else? Let's say this. Let C be equal if this, then C else underscore, and then we always add to the result. This is going to be better. Magnificent. Yeah, this is like the C mangling and stuff when you compile the other languages. I guess like we can also like make the IDs not this big, because we could make them only like, we can then be per name collision basically only. Then I wouldn't have the huge IDs either. All right, anyway. So, oh, wait a second. I expected a lib iterable over type t, but I got iterable over t. There's no way. Wait, is this a bug? So like we basically have t, which is a type, but like whether it's a type t or a value t, that's potentially a different thing. You know? Even though t is a type, we treat these as different types currently. I see. And how do I fix that? How do we fix that? There we go, now we have the underscores here. How do I fix that? I remember this was an issue before. Hello, Nix TV. Welcome. How are you? I have, so like, the issue right now is that in Kast, types are values, right? And so we, and like when the generics are involved, like over here, right? This over here is a t, which is a value, which is t, right? But this is a value, which is a type, but we don't really know it like immediately. We know it eventually, right? Like, yeah. Like maybe, like you see over here, we have type reference to t. Yeah, maybe if I say in more of these places, type t instead of just t, that would fix this bug, but it's supposed to work either way, right? But basically there are two representations of the value, which is a type, right? So the generics, these we call this the blocked value because basically it's only known at runtime, sort of related. Trait impl problem of JS. Null comma simple found. I'm not sure if that's the same. You think it's the same? I think this is a different bug. I don't think this is related. So there are two representations of a thing, which is a type that we don't know the concrete type of like the generic type variable, because we have like, because this is not necessarily a type, right? We can have the const generics, right? Or whatever you call it, the value generics. So we store the value, which we call the blocked value, which is like the variable, which we will only know at runtime, the runtime of the expansion of this generic, whatever that is, right? And yeah, but then we also have the types, and the types can also be blocked. So yeah, basically we can say T and we can say type T, and they are the same thing, supposedly, but they are not, which is why I have generated two types. Maybe I can do something, let me see. Oh, the input is on type foo, not foo. Oh, really? Okay, maybe it is related then. Oh, you implement type. Oh, I see. Okay, you should probably like say it here. Yeah, yeah, because yeah. Why are you doing type foo? And it works in the interpreter. Yeah, because in the interpreter, I think they are considered the same or something. Like this equality, yeah, is a little bit weird. So here's what we have, right? We have the value. We have blocked value, which is just a binding to a variable, right? So the value can be a blocked, but also a type can be a blocked type, which leads to two representations of the same thing, which are different. So, and that leads to bugs. So how do I make sure that it's just one representation? I don't know. It's not that easy. I mean, we need to convert from the value blocked to the typed value as soon as we know that this is a thing, you know? Cast types. Let's see here. So value new not inferred. Let's take a look at over here, right? New not inferred value. So this what's the context here? Normalized bindings. Anyway, the new not inferred value is a thing which knows that once we have inferred the type of the value, we potentially like do something here. We infer the value shape. But I think we don't do this when the value is inferred. Inferred value, yes. And if this is an inferred value, then we don't do this stuff. Let's also see that when I infer the value shape, right? If this is a, like, for example, if a value is a type, then we know that the value is a type. Yes, there you go. Which we then like unify them, unite value shape. So we unify if we know that something is a type and a value is blocked, then the whole value becomes a type, right? And I think maybe I can actually fix this easily. Can I like say over here, like, you know, can I say over here, like, once this is inferred, we know the type. And value type is none. Yeah. How about this over here? How do we like set up value shape based on type? inference of the value. There we go. Can do that. We also have new not inferred value of specific type. Not inferred, and then we unite type. Oh yeah, no, this is okay. I mean, maybe I just copy paste this. Okay, you know what? Whatever. Let's just copy paste it and see. Maybe it's okay. Like I want this to be done in the new inferred value. This over here, right? Yeah. So if this is inferred, but it's not like inferred whether it's a type or not necessarily if this is a blocked one, right? So this is like a special case. Yes. We also have like type is none. This was supposed to be an optimization, I think. I just want to say that if it is something, hold on. We have the shape, right? I want to do something specific if this is a shape. Right, and I'm going to set the type here. So match shape with, if it is a blocked, then we will do something. Otherwise we will see none, right? But if this is a blocked value, and then I have the type here, right? Technically, so there's going to be like some type. But I'm also going to say that once this type is inferred, match infer value shape on the scope. Okay, we also only want to do something if this is a type, I think. Match type shape. If this is a type, then we will do something. Otherwise, I will not do anything. So if it is a type, if we have inferred that this thing is a type, then I will this is the scope. The scope has type value shape var scope. Wait, can I just say scope is var inference var scope? Can I do that? We want blocked type to be type blocked B, which is a type, to be type blocked B. Right, there we go. This could be done maybe like in a simpler way, but let's just see if this fixes it or not. Wait a second. So now what we have is we have like the type T here and we have the type T here, but they have different IDs because it's different T's. Is it different T's? It probably is different T's. Indeed. Yeah. Well. I think it actually kind of makes sense here. Right? Let's take a look at this here, right? So this, yeah, there's a lot of iterable of A's, iterable of B's, iterable of T's. There's like 100 of those. There's iterable type underscore T, whatever that means. Iterable of int32 and T. An iterable over the ORD map type KV, right? Iterating over the key value pairs. Okay. All right. So the reason this is different T's is because like this is actually different T's. It actually is the case. I feel like I should not generate this many types though, right? And let's take a look at the insides of this type, right? Because inside of this type is just a function from something to the other thing, right? And this thing is just a function taking any type and returning something. Yeah. So if I understand correctly, the issue here, let's try to call this function. So we have a generic. Right? Let's try to have some function which is generic. Just cast anything to any. You heard it solves all the problems. Yes, but it breaks the optimizations. So we only want to use any. Any is like going to be used as the. I only want to use it for generics, right? Which means that we can. Like basically, it's a trade-off monomorphization versus using the any types, and the way the any type is represented in in like C, I guess, would be a void star, which we would need to like, which basically means that we need to box it, probably, or maybe not. I don't know actually. It can be still be like optimal in the case of C, but I think it cannot be, because like when you like, because the optimizer cannot optimize a generic function, you know, properly if it's done with void stars, right? If it, you can have a lot better optimizations when you do monomorphized types, right? So it's a trade-off here. We only do the any's as the for like the generic arguments basically, so that we compile faster. You need a fend pointer with a vtable type info. Yeah, but not for, it's not like exactly like this. You don't need a fed pointer. You can still have a pointer, but you need a vtable or type information somewhere. So the idea of the existentialization is that you don't pass the vtable or type info alongside each value, but like you know, if you have like a function which is generic, like minimum function, right? Like min is a function which takes a, which is t, and b, which is t, right? You don't need two vtables because the vtable for both of these types is the same. So you instead have a hidden argument over here, which is literally the t, right? Which is the vtable or like type info, right? And then you replace these t's with the any type, which is like a void star or whatever. Like this is literally what the existentialization means, right? And in fact, right now I don't even do this. I right now literally just say that this is a function that returns a lambda. So like this over here becomes the type info, which is the runtime type information, and this is a function that returns the function, you know, and whatever, right? But we could like also flatten this into a single argument. This is what Swift language does, and yeah. So they still do monomorphization for some simple stuff, but most of the generics, they are existentialized instead. So supposedly this should lead to faster compile times. When I fix the other things, the reasons why my compilation is very slow right now. I don't need to monomorphize. That's important for compile times. So the issue is, let's see here. I want to have a function. I think I don't even need the std or whatever. Let's get rid of this. Right? Let's just have the function foo is a generic over t, which is a function that takes t and returns nothing. And then just call, yeah, let's just call this function, you know, like apply, you know? So we are applying a function f with the argument of type t, right? And this should return the u, and this is like t and u, t into u, and this returns u, which just calls function f with the argument, right? Like this. So we're gonna like apply 1, 2, 3, which is an int 32, with a function which takes x and returns x, right? For example, can we do this? We have a pattern match that is not exhaustive actually. When I'm printing, when I'm printing, okay, so this is actually compiled, but this is not exhaustive for some reason. Oh, because I need to print the number literal, that's right. Number literal x output right to string x. So I think this actually compiles. Maybe. right? Looks like it compiles. And then we can say like native let result be this native console log result. Right? Expect expression got a reference. Wait, what? Wait, where is the reference? Oh, reference over here. Oh, because this is a place to have a temporary expression. Is that right? Yeah. This is another thing that is to do. Hold on. We need to like get to the other place first. Wait, can I like apply this recursively? You know, like apply EU FR, right? Like that's what I want. Recursively call this thing. Because that's, I think, what was not working. Which means that this must be in a module. We are unable to infer the type of the module. Yeah. Let's say that const foo is this, and then we will say like foo apply. Int 32. Let's make this over here. No, this still works. I'm not sure what's the problem. Is it? Oh, it's because I have a type there. Maybe. Right? Can I have the type here? You know, like result of type U. You know. So over here we'll say like result is U new type. F is result TU. F is T into U. Right? Can I say like over here that we return dot F is no, hold on. Apply the function is this, right? And this over here is argument into apply to dot F. Alright, a little weird. Maybe I did list T into iter next and expected T and got a different T. I'm not sure yet, actually, what's happening here. So I want to apply this function using 1, 2, 3 like this, right? Type is not equal to type. Right, over here TU, of course. Okay. I cannot break it. Wait, why can I not break it? Why can I not break it? Is it because I have a reference here? Okay, maybe if I implement this reference, it will like be complaining about the other thing. Right? What if I do this and this with an int 64, right? If I do it with two different types. Yeah, still the same problem. Okay, let's implement the reference expression then. So we have the reference and it must be an expression. Parse expression over here, parse expression impl over here, right? I want to say that if rule name is equal to reference, then referenced is the helpers expect single child with no name. So shape is going to be expression reference to something. Type is a reference. Referenced type. Referenced. Yeah, there we go. But the reference is at the ASD. We need to say that let expected referenced type is match expected type and none. So if we expected some type, it must be a reference type. If we expected some type match, resolve type aliases type, right? So if this is like a referenced, and this should be the referenced. If it's anything else, we should report the error. Expected, not a reference, but print type name type. Okay, so now we know the reference type, and we say that referenced is parse expression referenced using the type, which is expected referenced type. Okay, now we know this. I know the type. I know the things. And this should be it. Do I have the expression reference here? I do have the reference expression here, which also means, by the way, that this is not an expression. This is a place expression, right? That's what we're referencing, a place. External expression got value. Now dereferencing also should be there, of course. Now it needed dereference. So reference is this. Expected reference type is expected reference type is, if we don't know the expected type, then we don't know if it is some type, then we are going to just say that we need a reference, we need some reference to this type, right? Yes, so now we have the reference. Reference is parse expression. This must be a place expression. Expected reference expected reference type. So yeah, and now we say that match reference resolve. Okay, this is a reference type, and it's like the result type, right? So there's going to be a place of dref reference, right? And over here we say type. If this is a reference, referenced, then we return referenced. And in other case, we do the diagnostic error, right? Expected a reference got the reference, right? And this is not the EST span. This is the let's say called the reference EST. Reference EST span. Tutu. Hello, hello. Hmm? Mm-hmm. Tuta. All right, let's see if this works. But I am unable to infer the type of initialized. All right. So I think I will keep working next time. This has been a long stream anyway already, so let's finish it other time, or maybe I will check some things off stream. Boom, boom, boom. Mm-hmm. All right. Any ideas? Who to read? Let's read Tim. Here's some C++ for you guys.
Okay, beautiful.
Right, some C++ game development.
Everything needs.
Have a racing game.
Now, inside of...
See you guys next time. Thank you for watching. Bye. 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 Bye.